So Balamurugan sir.
Yes, sir.
Sir, shall we start, sir?
Yes, sir. Sure, sir. Thank you.
A very good morning to all. On behalf, yes, is it audible, sir? There.
Yes,
So
sir.
very good morning to all. On behalf of Department of Electrical Engineering, National Institute of Technology, I welcome you all for 5 days online workshop on advancements in electrical engineering and academic and industrial approach. So today is the second day, and we'll be having 3 sessions today. So the first session today is digital transformation in power system engineering by Dr. J. Balamurugan sir, Assistant Executive Engineer, Tangent Co. So let me give a brief introduction about the guest today. Dr. J. Balamurugan received his engineering doctorate in 2018 from St. Peter's University. He has obtained his Masters in Technology in 2011 from MGR University and Bachelor of Engineering in 2000 from Madras University. He has an overall experience of 19 years, in which more than 8+ years in installation, administration, and maintenance of various networking systems, hardware peripherals, Windows or Linux servers, firewall, video conferencing solutions. Then 6+ years in generation, transmission, distribution ranging from 110 megawatt to 660 megawatt generators, 230/400 kilovolt HT lines, 230 kilovolt gas insulated switchgear substations, HVAC operations, IoT, and smart metering. Recently, he has been elevated as Assistant Executive Engineer, Commercial, looking after DSOP, LOP, and tariff revision. Earlier in his office, he was working as an Assistant Engineer, Electrical for IT Division, looking after servers and data migration process for prestigious Central Government Project RAPDRP, first of its kind data center in Tangent Co. He has organized more than 25 workshops, 10 symposiums, 30 seminars, and delivered many technical lectures for finding solutions in emerging engineering needs. As a measure to impart energy conservation, he is in the process of developing a portal to connect many premises through IoT in implementing DSM, which is the ongoing research work. He has delivered lectures in numerous engineering colleges on emerging technologies like renewable energy sources, electric hybrid vehicles, IoT solutions, home automation, blockchain, energy auditing, AI-based algorithms, ETAP, and PSSE software for engineering students. He is currently the elected committee member for Institution of Engineers, NGR. Sir, we are privileged to have you with us, sir. Now I request the guest of today, Dr. Balamurugan sir, to take over the session.
Thank you so much for a wonderful introduction, Srijit sir. So thank you for the organize as well. So
thank you, sir.
I'll share my screen. Is it visible, Srijit sir?
No, sir. Just presenting.
It's presenting, right?
The presentation is not there, sir. Just it's presenting. 1 minute, sir. Let me wait.
Okay, let me try it again. Okay, let me try the entire screen. Is it visible right now?
It just started presenting, sir. It's not visible. Presentation is not there.
Yeah, again and again. By now again.
Yes, sir. It's visible, sir. It's visible.
Okay, great then. Okay, fine. So I'll just go ahead and yes, okay, fine. So a very warm and welcome to all the participants who are there in YouTube as well as watching in our college. So thank you so much for the opportunity that has been given to me. So I'm now here to present about the digital transformation in power system engineering. So that's the topic that has been assigned to me. So it's a warm and welcome to all such participants who are enthusiastic to listen to me. So I'm not going to give you a promise that I won't bore you for next 1.5 hours. So I'll just make sure that the content what has been taken is all related to power system, and it is not a copyrighted information, so anyone can share it. Thank you so much. So is it interactive, or I can just go, it is monotonous session, so they will be talking, seeing the board, right? And that's it, Vijay. Is that would the people would be able to listen, chat with me again? Srijit sir? Okay, fine. Okay, so let me start about me. So it's expectation from the speaker. So it's about the advent of fourth industrial revolution. So that is going around, and we could see that this pandemic has brought about a change as we are isolated in our home, but we are connected. So that is the era of fourth industrial revolution. So that's the main thing. And we could see that building a cloud-based intelligent personalized learning services that is to be enabled. So that's how we are connected through Google Meet or Zoom or whatever it may be the media. So that's how the intelligent system is going to identify ourselves in connecting such technical data back to the people. And moreover, we could see that there are a process going on that no such people are coming to our home for taking up reading, but we could see that our money is automatically deducted from our account for energy billing. It's a shock only, but still they're moving towards the digital era. So we need to think about AMR and AMI getting inside our house. So that's the opportunity we have. So no more assessors or the people who are about to take up the reading, they would be coming to our home, and the meters would be automatically talking to each other. So that is also being done by artificial intelligence. So we'll think about it. Let's have what's the digitalization that's going around. Let's have a video. So because it is something like we are in an isolated room, we do not know how many people are sitting beside the bed or again the computer. But let us make it more interactive, making a video. Okay, so we could see that the transformations which is going around the world, and we could see that a lot of changes going around the digitalization of the entire process, and we could see that the roads due to pandemic there is no traffic or road density, but we could see that this automobile industry would be wiped off, or it would be doubled depending on the technology that we electrical engineers are going to put forth. It's not alone electrical engineering, it's about the engineering. So what we are going to deliver is very much important. So in that case, how this is going to transform ourselves to this smarter world. I hope I am talking with all such smarter people. We need to think about smart connectivity. So how things are going around us. So it's about the electrical engineering and how a smart world, because I don't want to give the PPT. So I have such PPTs to explain, but still a video would give more value. So I'm going to add up another video. It's not, it's the extension of the digitalization that is going around us. So it's digital world, right? So we need to think about digitalization only. Okay, so
our current electric grid was conceived more than 100 years ago when electricity needs were simple. Power generation was localized and built around communities. Most homes had only small energy demands, such as a few light bulbs and a radio. The grid was designed for utilities to deliver electricity to consumers' homes and then bill them once a month. This limited one-way interaction makes it difficult for the grid to respond to the ever-changing and rising energy demands of the 21st century.
This is what happening now. So I'm just monotonously talking. It's one way. People could listen to me, but they could not respond. So I would always prefer to have two-way process of communication. So that is going to be more interactive. My communication is going to talk with my utility. So this utility is going to talk to me, that switching off my computer, switching off my laptop, or switching off my AC automatically depending on my energy billing that I have configured.
The grid introduces a two-way dialogue where electricity and information can be exchanged between the utility and its customers. It's a developing network of communications, controls, computers, automation, and new technologies and tools working together to make the grid more efficient, more reliable, more secure, and greener. This smart grid enables newer technologies to be integrated, such as wind and solar energy production and plug-in electric vehicle charging. With our participation as informed consumers, this smart grid will replace the aging infrastructure of today's grid, and utilities can better communicate with us to help manage our electricity needs. The smart home communicates with the grid and enables consumers to manage their electricity usage. By measuring a home's electricity consumption more frequently through a smart meter, utilities can provide their customer with much better information to manage their electricity bills. Inside the smart home, a home area network, or HON, connects smart appliances, thermostats, and other electric devices to an energy management system. Smart appliances and devices will adjust their run schedule to reduce electricity demand on the grid at critical times and lower consumers' energy bills.
So this is what called DSM, so the demand side management. So when the demand is high, automatically our equipments will be switched off, and when there is less demand in the utility. So we have always a demand because we are connected with the grid. But when the grid has major demand, our voltage would be lower, and so the current carrying capacity would be higher. So in that case, the current billing may go an extra mile so that we could not poke our pockets. So that's how the technology is binding and giving us an advantage that the equipment itself would be talking to the utility in order to make sure that whenever in the night time, so going back to the home, we could see that all our dresses need to be washed for tomorrow's opportunities. So in that case, we need to clean the clothes, but we would be dumping in the washing machine and we would be switching it on, but it would be in operation only when the load value is very low. In utility side, not in our home. Okay.
These smart devices can be controlled and scheduled over the web or even a TV. Renewable resources, such as wind and solar, are a sustainable and growing source for electric power. However, renewable power sources are variable by nature and add complexity to normal grid operations. The smart grid provides the data and automation needed to enable solar panels and wind farms to put energy onto the grid and optimize its use. To keep up with constantly changing energy demands, utilities must turn power plants on and off depending on the amount of power needed at certain times of the day. The cost to deliver power depends on the time of day it is used. Electricity is more costly to deliver at peak times because additional, often less efficient power plants must be run to meet the higher demand. The smart grid will enable utilities to manage and moderate electricity usage with the cooperation of their customers, especially during peak demand times. As a result, utilities will be able to reduce their operating costs. By deferring electricity usage away from peak hours and having appliances and devices run at other times.
So I need to make a point that the black fuel, so the utilization of black fuel as restricted to 57% for the utilities, that the plant load factor. So the maximum operable time period that has been reduced to 57%, it is half. So it's something like the base load has been reduced drastically. So that means that the grid is automatically driven only by renewable energy. So that's how this picture gives us information.
Electricity production is more evenly distributed throughout the day. The power being used right now was generated less than a second ago, many miles away. At each instance, the amount of electricity generated must equal the consumption across the entire grid. Smart grid technologies provide detailed information that enables grid operators to see and manage electricity consumption in real time. This greater insight and control reduces outages and lowers the need for peak power. In control rooms across the grid, engineers will be able to more precisely and predictably manage electricity production, reducing the need to fire up costly secondary power plants. The distribution system routes power from the utility to residential and commercial customers through power lines, switches, and transformers. Utilities typically rely on complex power distribution schemes and manual switching to keep power flowing to their customers. Any break in this system caused by storms, bad weather, or sudden changes in electricity demand can lead to outages. The smart grid.
We could see that the Urja Mitra, so the scheme that has been implemented throughout the country, we could see that in another 5 minutes the power is go down, and you would also get an SMS once it is resumed. So you would get an SMS that the power is going to be there. But we need to have power charged, because to receive SMS we need to have the cell phone charge, so that depends.
Distribution intelligence counters these energy fluctuations and outages by automatically identifying problems, then rerouting and restoring power delivery. Utilities can further use distribution intelligence to predict and manage electricity usage with the cooperation of their customers, leading to lower production costs. The charging of a plug-in electric vehicle can be managed over a home area network, or HON. The HON can balance the demand for electricity across the household and prioritize between the electric vehicle and other appliances to manage electricity usage and reduce costs. With smart grid technologies and consumer participation, utilities can more easily handle the increased demand for power to run the electric vehicles and ensure charging needs are met. By adding more plug-in electric vehicles to the grid, we have the potential to reduce fuel costs, lower our dependency on foreign oil, and help reduce greenhouse gas emissions.
Okay, so thank you for watching. So we can see that all such technologies are behind, or it's ahead. So we need to think about it, and I'm here to talk about discussion only. So it's something like whatever I have learned, and I just want to share to you people so that I can also learn in the meantime. So it's the agenda talks about the power system, industrial automation, fourth industrial revolution, intelligent system embedded in power system, analysis, areas of improvement in, and the students' opportunities in system power system industries. So myself, Dr. J. Balamurugan. So I think that everyone is a genius, and I'm talking to all such genius here. But if you judge a fish by its ability to climb a tree, it will spend its whole life believing that it's stupid. But we need to think about that no more we are addicted, or we are into electrical system. It's about the generosity that has been thrown So we are very smart, and we need to think about the engineering is no more electrical engineering. It is about communication, the information, or mechanical, whatever it may be. So that has been binded to engineering. So that addresses it. And also I need to give a very good word about this. Learning happens only on two situations. One is about the fear, and the second about the objectives. So we always learn on the fear. So I could give an example. So there is a tremendous learning in army or the forces. So usually the people would be trained to climb 60 feet actually through a rope. So when everyone was climbing, one such guy could not climb, so he just climbed around 56 feet, and then he was crying like anything that he would fall off from this rope. So the leader, so what he did is something like he just took a rifle and just shot the rope so that it is behind his leg. It's not 56 feet down the line, but it is automatically cut down. So what happened is something like by seeing the bullets nearing the rope, he just climbed it in a seconds, and he was sitting on the 60th feet. So whatever may be the target. So he was crying like anything because he could not do it, thinking that he may not be able to do that. So that is the fear. So that's where we people always learn about it. So we also think that if they are not going to pay me the salary by next month, I need to do something for it. So that's the learning we have about different subjects as well. So or else we will take up only one subject that is very comfortable to me. So I'll be taking the same subject, all specialized things. So the fear, it's something like a forget everything and run, or face everything and rise. So we need to think about the failure. So our beloved leader used to say fail. So fail is the first attempt in learning. So learning is the process that happens everywhere. I am also take this opportunity to learn about these things. Okay, so the power system engineering. The power system engineering is an important branch of electrical engineering that deals with the generation, transmission, distribution, and utilization of electrical power. So the general information gives about the power system. So it's about the electrical engineering. So we also have a visionary objective that has been taken over by India. It's the third largest producer and the third largest consumer. Why I should make a point is something like when a northern part of the grid gone away, the Google has recorded world's worst blackout has occurred in India. So that means that world's worst blackout means it is only a portion of India, so that was blacked out because of some reason, so technical glitch. But we could see that Google has recorded there is such a blackout. And we could see that during this pandemic, when we were about to clap or we were about to light up as per Honorable Prime Minister that he gave an idea to chase away this corona, we could see that the entire grid was tumbled actually. So in that case, there was no blackout. So the Indian grid managers were competent enough to do such work that it was anticipated before 2 days, and even below 3,000 megawatt was scattered when the demand was 15,000. So that's how the managers have a lot of technicalities, and we engineers need to be very proud that we have such technologies binded in our utility, so that during this pandemic situations, no such power cut happen around the country. So that's the managerial skills that we have. And electrification achievement. Even before 1985, Tamil Nadu was the primary to achieve 100% electrification in rural areas. But even today, so we could see that some of the part of the countries are not being electrified. But the Saubhagya scheme has brought a change, making 100% electrifications by March 2019, and it has achieved 24.7 million households have been electrified because of this. It's rural electrification. So robust growth in renewables. We could see that lot many changes are going around. So this is the power sector. So that's having a transformations of Electricity Act 1948, which gave introductory stage. So that's something like hydropower stations and thermal power stations were about to come, and when it was the power supply was given to extended to some high-rise buildings, so they had an opportunity to taste this electricity. But nationalization brought a change that everyone can taste this electricity and they can own a radio. So we could see that the Marconi invented the radio before independence, but they didn't have the rights to own it. So they were paying tax. The same thing happened at the nationalization stage, and the liberalization were given. Anyone in India, any part of the country, they can have this electricity, so they can enjoy it. So that's how the liberalization came into play, and the liberalization also gave an idea that anyone can generate the power. So that's how the liberalization came into play. And by 2003, so we could see that the Electricity Act 2003, which is governing right away, we could see the amendments are going on a regular basis, and we could also see that there was an amendment called Electricity Act 2020. So that's how it's a draft bill only. It's going around. But the growth era is something like the distribution. So we don't want to depend on the transmission as well as the generation. So the people themselves would be generating. So that's the power sector revolutions that's going on. And we could see that the thermal, it's going back. So which is something like a 63.54% of contributions that is given by this thermal power plant. It would be extinct, or it would be coming to a 0 point. Yes, which is going to take over. So the next highest source that is connected to the utility is the renewable energy. It is 21.80. So which is going to be a boon, and we could see that our climatic condition. India has only 3 climatic conditions: hot, hotter, hottest. So that's how in South India. So I don't want to claim it for North India, but it's something like the climatic conditions really, it's a boost to this renewable energy, and we could see that we need not waste the resources. We can keep it for the future. And we could also see that we don't have any rivers in South India. It is not perennial water resource. Throughout the year, we don't have the water resources. Although we are planning for this water grid, like that of a power grid, but we do have all such of pains that is going through between the states. So not cooperating, or it may be a damage like that of the world's largest bridge in China. Could see that these hydro projects are a big challenge to the environment. So that's how. And we also about to stop this nuclear energy. So we are about to take off by only 1.9%, but due to the engineering drawbacks, so we could not go ahead and have this nuclear technology, which is age-old technology that need to be upgraded. So now we have our own breeders. That is an advantage. So we could see that MAPS having such opportunity, and Baba Atomic Research also go ahead with this technology. So we engineers need to work on it. So we have 3D translations. So that's how we are into this power system. So it's about the digitalization, digital India. So it's about the decentralization. So we are disconnected, but we are into the system through Google Meet. So that means that we can always take up the class. It's not that if in your home we could not take up the classes, or we could not make it more interesting. But we could see that the centralization is being decentralized, and we can participate, and we can also have 100% contributions to it. So, and we could also see the decarbonization. So the ozone layer is automatically closed because of this pandemic situation. So that is a big opportunity, because climatic conditions has made us to move from thermal energy or the black fuel to green fuel. So they say somehow or other we need to reduce the greenhouse gases. So that's how this decarbonization is going to be the tremendous change. So these are all the 3 Ds. We also need to think about it, and the 3D technology in power system. So it's about the digitalization, decentralization, and decarbonization. So this is about a decarbonization, digitalization, and demarketization. So it is electrification with more renewable power, systematic innovation for enabling energy digitalization. Technology is progressing for decentralization trends. That's how it goes on. So I have already given it in the video, but we'll just move around. So this is about the digitalization. So a pilot from the cockpit, he says that this is your pilot speaking. I'm working from home today. So that's how the change is going around about the digitalization. So it's a panic or it's a happiness. We need to think about the digitalization. So let's begin this journey. So it's about the journey we need to work hard on. So it's about the smarter connectivity. So we are smarter, so we need to have a smartphone, but we do not know how much percentage we are utilizing. So the smartphone has all such facilities, but we can use only for 40,000 mobile is used only for taking up the calls, or it's for messaging or through WhatsApp. That's it, nothing more than that. So do we have this app store not been utilized? Yes, I do see that a lot of things come out. The earlier WebEx Cisco was there, but people doesn't know what is about the Zoom meeting. We could see that a lot of opportunities were there, and we could not connect with the smartphone. Nowadays, we also think about an opportunity connecting such digitalization. We need to be very smarter in connectivity. So existing electric grid should be transformed to smart grid, means we need to have the ICT technologies so that is being connected. So it is something like we need to work on with this index. So it is about the SCADA, DMS, ADMS, the supply reliability through SIDI SIFI. So SIDI SIFI is the indexing factor, so that need to be worked on. And the green energy, so electrification, so it's something like a photovoltaic cells need to be connected to the home, and it is powering the home. Apart from powering, it should also have the opportunity to supply back to the grid. So that is an opportunity. And customer empowerment satisfaction, real-time data to customers. It's something like the meter after 2 months giving a bill data of 2 lakh rupees that is being sent as an the energy bill. It is a shock, but we need to have a real-time data that your AC was switched on 30 seconds before, and you have washing machine switched on, and your gas connection has been switched off or switched on. So these are all the digital data. A relay would pull up a data, and Arduino would have such that low power computers connected to the metering point would give such information. It doesn't have a duplication, but still we need to have a customer satisfaction. So there is also a feedback from the customers, so the utility doesn't work monopoly. So data analytics, this is very much important, because nowadays we could see that the data forecasting, so intraday data is 100% accuracy, because this data analytics has given a lot. And the DSM, whenever the people doesn't have the demand, actual demand is not there, then we can switch off all the power stations. We need not have it in standby mode. So that's how the smarter meter cover this particular part, and the digitalization is going to be a boon to us. And the integrations of this distribution energy systems, so management of TER integration, grid scale energy storage. So that is very much important. And going forward, the security is very much important. We have such threats. We need to be an IT engineer in tackling all such things. If the power grid is taken up by hackers, then what is going to happen? We can't imagine about it, but we need to think about it. So these are all the opportunities working with that one. So we need to have an intelligence added to the system. So how the intelligence is going to have an interaction? So it's something like it is the power plant, transmission system, distribution system, and the customers are going to be getting connected. And it is about the connectivity that is being done through LAN, WAN. But now we do have this wide area monitoring control. So where this WAN is going to be connected through smart meters, and the smart meters in turn would have this AMI, that is automatic metering infrastructure that has been connected, and the distribution grid management would be controlled. So by that, the DSM is going to be calculated, and accordingly the data is going to be fetched to the load dispatch center. This load dispatch center would have an artificial intelligence embedded to this, and we could and imagine Electra. So what to say, like a robot sitting behind the load dispatch engineer and talking. So what is the demand right now, Electra? Yes, it says that the entire country has a demand of 1 lakh megawatt, and from northern grid we used to get this much megawatt, and southern grid has this much load, and we need to have the generation scheduled, and we have a downtime of what to say, like the HVDC night can be kept off. So like that of information should be analyzed through the artificial intelligence techniques that is being worked on. So we are working on with more such simulation, and we could see that this 3000 megawatt which gone from 15,000 megawatt to 3,000 was tackled by all such engineers during this pandemic situation. So that's how the intelligence has been added to the grid. So going forward, we would have an idea how things can be embedded, and how this can be giving an opportunity for all such engineers to work on with the research and the employable opportunities, and the demand that we have for the engineers, for such engineers. The problems are the demand. When there is a problem, we need to make an opportunity to resolve it. So we shouldn't have a panic. So that's how. So it's about the target. I skipped the slide earlier, but I just want to show it off here. So it's something like 175 gigawatt year 2020. So we just organized a conference with all such people, and one such question was posted to the grid manager. So whether it is a joke that we would be achieving this 175 gigawatt by year 2022, sir. So the manager was politely and humbly, he gave an answer that even during this pandemic situation, we are working on it, and the vision has been already achieved, and it will be thrown to the public by 2022. That is the positive answer we have from Indian engineers. Hats off to the people. So we need to think about the 100 gigawatt from solar, 60 gigawatt from wind, and 50 gigawatt from biopower, and 5 gigawatt from small hydro power stations. All such opportunities are coming into system only because that we engineers have transformed everything, and we could see that before independence, it is something like even the grown-up country could not achieve. But with this much, the second most populated country could achieve this much is it's an enormous thing. So that means that the digital connectivity has transformed the power sector system to a greater level, that unreliable data. It's something like we need to think about the renewable energy, means it's always renewable, because it is on a daily basis, we could see that the power of solar is very high. The power of wind is so high. The power of biopower, it's something like an urban utility. So like say Greater Chennai Corporation could collect 1 million tons of garbage coming from urban sector, and market. So vegetable market could get this much wastage, means the vegetable waste are being dumped, and it is like a menace to the society. But now the electrical engineers has transformed everything to power. So going forward, this Bloom's technology would be coming from our NIT. So like it's not Bloom's box. We would have much more greater opportunity from such engineers coming out with no wastage, no residual wastage. So that's how the technologies are binded. So we need to have the digital transformation, means we need, the data is very much important. So always the data is there. The peak power demand in India is rising up by 690 gigawatt. So that is something 3 times higher, which was in 2009 it is 119. It is 690. So even if we consider this 300, that is by prevailing, that would be prevailing by 2021-22. So by another 15 years, it is going to have a rise of 690. So that means that the highest consuming power, like say, people could think about the motors are consuming higher load, but the charges are going to eat up something. A single bit of charges which is kept on is also been recorded by the smart metering, that it is a static meter that has given an opportunity. So that means that the losses are going to be minimized, but still the demand is rising like anything. So how we are going to tackle it? So we are about to have the cultivate an opportunity to have this renewable energy integrated to the system, where the resources are always flowing. It is being diverted to convert to useful power. So that's how this renewable energy be categorized into hydro energy or other forms of renewable energy, because earlier, before 2019, there was no law which framed that hydro energy was in renewable energy. Now we have small and that is hydro stations were listed in renewable energy, but now the entire hydro system, it's a large, small or medium, that is been included into renewable energy system. So that's how this law has been binded, and we could see that hydro energy plus other renewable form of energy. Small hydro power projects is lesser than or equal to 25 megawatt, that is been listed there as other renewable energies, and wind power and biopower and solar power are other categories that is listed in renewable energies. So biomass power and urban industrial waste to wealth. So every engineer can work on it in the home itself by planting a self-sustainable home. So that means that the power would be given by the solar, and the greenhouse gases would always cultivate the vegetables in their rooftop. And also we could see that the wastages coming out of our home can be converted to biogas and biomass. So that helps in cultivating the vegetables as well. So Indian renewable sector, it's something like it's growing from 2013 only. So the technology has brought a change, and it is rising from 17% to 21% as such. So it is going beyond this level by investors. So what is the investment that has been created? So it is about the growing demand. So when the demand is there, always people can pump in. I can give you an example. It's something like a Power Finance Corporation, which was earlier the share market had only 200 or and we people as an electrical engineer need not think about getting a job, but investing in IEX. There is a power exchange which is going on, so people can think about purchasing power and distributing to other things. So that means that the digital connectivity has brought the power sector in a growing stage, and the foreign direct investment through NRIs are coming up, and all these renewable sectors. So people earlier were having an opportunity to hold agriculture lands, but they are investing it in the double way that the solar panels are being listed there, so automatically. So that's the opportunities that we have. And why such renewable energies for India? It's due to this power shortage, rising prices of oils and gases, ecological hazards, ample resources and sites available, abundant sunshine, government incentive, increasing finance options. So benefit of renewable energy is avoid high cost involved in transmission capex, avoid distribution losses, technical otherwise, and avoid recurring fuel costs, boost to rural economy, encourage self-help groups to enable all such things. I don't want to get into such things because we can directly get into the digitalization. So how things need to be there, and how as an electrical engineer we transform ourselves into the digital data, and how we can connect with that. So wind energy. So wind energy is also a boon to all such people right away. So we could see that a lot of opportunities are there for wind energy. And MNRE, Ministry of New and Renewable Energy, has proposed wind power capacity addition of 10 gigawatt each to be awarded by fiscal year 2020. So 1920. So as such, 2018, the MNRE has first interstate has established the first interstate transmission system, ISTS, option with wind power capacity of 126 megawatt. So the people could see that starvation is going around with the grid. It's such that 10% of the energy which is being generated by a state or a percentage, we could see that we can keep it in the other way around. A percentage of energy that is being generated by the state utility should be green. So that's the opportunities for every state to invest in this renewable energy. Means we are about to have this much data, and we are about to have all this unreliable, that is not at all reliable. These sort of renewable is going to bring a change to the grid. Means it is all connected through data. It is because of this digitalization. The solar energy. So we are talking about renewable energy. Means the boon is always there. So off-grid solars, off-grid applications of 2000 megawatt is being planned. Rooftop projects of residential and commercial has been it is already been connected with 40,000 megawatt. And solar parks, developing solar parks and utility scale up to 40,000 megawatt. These are the large scale projects to connect this 100 gigawatt by 2022. So such projects also been there. So we could see that the concentrated solar power is also coming up with the molten salt or molten sand that is having the thermal energy being tapped through the photovoltaic cells, as well as the concentrated cells that would be converging the heat energy, and thereby the heat energy is again converted. So the conversion ratio need to be reduced. Means, but here the efficiency of photovoltaic cell is very less, very minimal. You could see that the 8 to 18% of efficiency is not going to be a boon to us, because going forward it is a menace that how we are going to discard these solar cells, because it cannot be decayed. So but we need to think about an energizing factor so that we can bring about a change, improved efficiency. That's how we have taken up the hats off to these engineers who have brought a change that each and every opportunity is an advantage to this energy sector, the power sector. So major players in power sector. So I just want to have a glimpse of these people, because they are into the system, and we also can make sure that connecting with them would give such large data, pooling of data, as well as employment opportunities are also there. It is about the NTPC, Tata Power, Reliance Power, CESC Limited, NHPC, or these are all the public sector utilities that is governing. So PFCs, Adanis are there, the private sectors. We could see that the largest solar power was installed by Adani Power in Tamil Nadu. So now it has been taken over by the other state. Yes. So we could see that the Power Grid Corporation, so Damodar River Valley Corporation, first of its kind, who installed the power corporation in India, Damodar River Valley Corporations. And we could see that SJVN Limited is also into the hydro system, where this renewable energy makes a vital role. So key industry association. So we need to think about the organizations or the nodal agencies who are working there. So we could see that NICE, National Institute of Solar Energy, we can connect with them to get all such data, and we could also have such connectivity in research works. They have a lot of informations, and we can connect with them to get research ideas, as well as we could also give a solution to them, connecting with them. National Institute of Wind Energy, where the intraday and the intraday connectivity is there. So I could give you an example. It's something like what is the importance of these agencies is something like for an aeroplane. So if it is delayed by 5 minutes, the entire schedule of the aeroplane around the world would take another 30 to 60 days to come to normalcy. So that is the data that we have. So that means that we need to have a data pooling of 60 days data. So that means that if rain is about to come, we need to have a preciseness saying that by 7:27 there would be raining in the city, in part of city, or it is in the urban part. So it's something like the heat energy that is going to transform this wind power. Means the heat and wind are interconnected, and the data is always there with NIVE or NICE, and so that we can get a research opportunity there. And we also need to think about Sardar Swaran Singh National Institute of Bioenergy, where that is biomass and biogas power plant can be established, and the data can be connected with it. the Indian Renewable, IRIDA. So it's something like the TEDA or IRIDA or the nodal agencies, so that can be connected where the data can be pulled from them. So this is about the SECI also. SECI is a Solar Energy Corporation of India. So they have such data. So now coming to the digital transformation. So why I was thinking about all such, I have titled it as digitalization in modern power system, but I was going on talking with the system, means I need to identify the problem. If the problem is not there, why I need a solution? It should not be a backlog to me, or it should not be a burden to me. So if the burden is there, so that is the problem for me to adhere to it or live with that. So it is always a problem. So if at all, if I am not looking at that perspective, so connecting the digital information, it's a problem. So we could see that earlier our kids were denied of mobile phone. I do not know why we denied it, but still we were stopping people watching the mobile phones, smartphones. That was a menace. Going on tapping this cell phone, it's a problem for all such kids. Now we are asking them to sit behind the smartphone. You take this smartphone, guy. You need to take up the classes today. It's a joke, or we need to think about it. I do not know. The same way, the problems are going to be there. So the problem need to be resolved and it need to be addressed. The problem is something like we have an opportunity to work on with renewable energy, but why we need the digitalization and how the digital data is going to connect with us. So it's all about the integration. So these are all the issues that need to be solved before getting into the problem. Because the issues, if it is escalated, that would be a problem to us. So in that case, the data forecasting. So always we used to have a joke saying that lift your two fingers and say that if the middle finger has a good opportunity, today there would be sunshine, or today there would be a wind speed of 40 kilometers or 60 kilometers. Depending on it, we can generate the power. So it is the data forecasting. We don't have such data. So if the data is not there, then how could we have the intraday and the intraday prediction, thereby connecting the grid? So the demand is always going to be there. So we could not say that we can stop this, but we need to have a data forecasting with the digital connectivity and scheduling flexibility and incentives to be there. Earlier it was we said that importing coal was very high, and so the cost was around 1 rupee, 2 rupee, and we said that we are moving towards renewable energy and it is all free. So incentives were planned, but today we could see that in the lockdown everyone were safe in home, and we could see that the bill, who could not even pay the rent, they could pay 10,000 rupees to 20,000 rupees as the electricity bill. So in that case, why I am telling, I am not in the negative sense, but I need to put a forward that the incentives are about to be given, means we need to have the generating capacity higher, and also it is distributed to the such load centers without any loss. And we also, for taking up our what to say, like consuming the power, we are going to get incentives. So that's the opportunity we have, means how we are going to schedule it. We would imagine. So going forward, I'll give an example, but I'll just go ahead. So day-ahead market participation and reliability commitments. So it's about the day-ahead participation. It's something like we have long-term agreement, short-term agreement. So that is going on with the power purchase. So in that case, the power purchase, the managers are not liable. Then we could not get the power 24/7. And we could also see that if the data is not there, the share exchange doesn't have any digital connectivity, the share market is going to be down only. It's not that we would get a data sent through this sparrow or other birds. We need to have a digital data, so it is very committed, and also it need to have a reliability and balancing authority coordination. It's something like always we talk about water grid, it was never achieved. Even before 50 years, we were talking about a water grid only. This Kuam, that is the one of the finest water which was connecting the Buckingham Canal. Okay, so that was giving the transportation. The cheapest transportation was there. If that was connected and a dam was connecting that, and we could see that the power can be generated from that end, and also the transportation could be achieved. But it was not there. So balancing authority coordination, so that we could not interconnect any such river, Krishna or Godavari or Ganga or Brahmaputra. So whatever it may be, we have always the problem, but balancing authority coordination should be there. Reserve products and ancillary services. We could see that the thermal power plant was established only to generate power from black fuel. Now sugarcane industry can generate the power, and copper smelting company can generate power, and the vegetable wastage, so that is been thrown out of the vegetable market, can generate power. So in that case, each auxiliary services are working, means these ancillary services, it's something like the storage and other things need to come up. So that means that it is not storing the energy. So there was a myth saying that it would be like energy can be neither created nor be destroyed, but can be transformed to one form to another. That case, energy cannot be stored means, but now we have the storage. So the storage need to be planned. So small capacity system design need to be there, economically not viable due to conversions. So it's a small capacity means we are throwing off this transmission end itself, and we are going to have only distribution end. So it is about the we are talking about distributed generation. So that means that we are not going to connect with the transmission system. Actually, we generate and we consume. We are skipping that one. So whether it is economically viable means a smaller segment going forward would be advantage, but without this transmission system, it would be a trouble. And real-time adjustment should be there. So net metering. Earlier it was net metering. Now it is not net metering. The accumulated data would be paid off, and no more money would be given to you. So that's how this the real-time adjustments. So solution is that we need to have hybrid systems, renewable resources, conventional resources like PV diesel hybrid system, energy storage technologies need to be added up. But if that need to be there, all such things need to be connected through digital, and the data should be there. So grid reliability remains high with the increased wind production, means improvements in wind forecasting tools and wind technology help with the grid integration of the wind power. So always I talk about this forecasting. So we just don't have intelligent system to forecast, means we are not going to tap this wind power. Increasing wind power production, it decreases the fuel consumption. Decreasing fuel consumption result in fewer greenhouse gases. So I was talking about the 3D. It's about the digitalization, decarbonization, and then it is about decentralization. So decentralization is something like all such data need to be pulled into a single data server, and the data analytics need to be done from that particular server. In that case, reliability is not there. This tapping would be zero. Yes, the wind managers don't have an opportunity to connect with a regular grid system. So communication among all energy networks. It's something like the smart generation should be there. That is coordination between wind, solar, biogas, or whatever may be the renewable energies or non-renewable energy that need to be integrated. It need to talk to each power plant. That is the smart generation. Smart distribution should be there. It's about the AMR and AMI playing a vital role in connecting the demand versus generation. So it is about the smart distribution. Smart consumption is there. It's not paying much. Earning money means it's not paying to the utility. It's something like we need to talk about energy conservation. Energy can be neither created nor be destroyed, but can be transformed to one form to another, means we are about to be a menace to the society, means we need to reduce our power. Reducing power is always not a good option, means then you are a problem to the country or the continent as well. because you are not cooperating with the energy conservation policy, and you are not even adhering to switch off every day the counterpart, whoever it may be, the spouse, they would be calling while going to the bathroom. You are switching on the light, but why can't you have the responsibility to switch it off? Because it's something like we would give a lame reason. So it was due to urgency we went there, but we don't have the responsibility to stop it. So whoever it may be, so both the people in the house, they would have the what to say they always work on with the instructions only, but they don't adhere. So it is about the smart storage. The residual power that can be, it may be in a smaller thing also, that can be stored and it can be utilized. Earlier, renewable energy was not reliable because there was no bridging technology behind it. So now we have the bridging technology, the storage can be done, and thereby Australia, we could see an example that Tesla has established it with a challenge. It was 100 days challenge thrown to Tesla, but even before that 83 days, it was established, and the island, Australia is an island, we could see that the 365-day power is being generated through renewable energy, and the storage has given a mileage to them. It's something like 8 hours of energy can power them for an year. So that's the opportunity we have. So that need to be communicated, that need to be connected. The focal point of intelligence is something like we are going to connect with all such network. So 100% efficiency need to be brought out, means we need to integrate renewable energy. So we need to connect e-mobility. We need to have the security, supply and network expansion should be there. Decentralized energy production should be there. Load flexibility should be there. So savings should be there always. So intelligent measurement is very much important. So in that case, IT security and data protection, it is a mammoth task that need to be taken care. So in that case, digital connectivity should be there. 230 volt and 2 volt need to be interfaced. So if a shock is there in your internet, then it is you people won't be connected through internet. So that's and we need to have a market liberalization. It's something like India alone has least cell phone. Earlier, even today, people used to give missed call only. Even if it is free call, people give only missed call. It's the market liberalization that incoming itself, it was 8 rupees and outgoing was 20 rupees. Now you see that for 599 rupees, you could see that it is 2.5 GB of data that is free for you. It's not calling. Calling is free. Data is alone being charged. Going forward, 5G network would come up, and we could see that all our appliances are connected to it. So that is the opportunity. So we need to think about the focal points. That's there. So electricity initiatives, new generation technologies need to be integrated through smart pan-India transmission network, and the smart network and processes need to give a leverage to smartly integrate it. So the integration need to have the energy management. This energy management need to give an opportunity to have a digital connectivity of smart functioning. So smart grids functional level, it's something like the customers are being connected to the ESCOs, so energy saving companies, retailers, aggregators, and the distribution network and the transmission network. So it is in the positive sense that it is being expanded, the triangle which gives a value, the customers are most valid than the generation. So that means that this distribution network need to be connected through this ESCOs, and thereby giving an opportunity to digital connectivity. So smart grid versus customer benefit. So going on talking for next 30 minutes is horrible. And so we could see that how the digital data is going to enable us or taking advantage of it.
Our social and economic well-being is underpinned by essential service networks, including electricity, gas, and water. Managing these networks is becoming increasingly complex as they expand and old infrastructure is replaced. Executives are also facing challenges as new forms of generation decentralize supply, and today's customers have radically different expectations of products and services. To remain in control, connected, and relevant, embracing digital is essential. It is a deep integration of technology, operations, and behavior throughout your organization. Embracing digital will change your relationship with customers, enable new products and services, increase network reliability and operational efficiency, and strengthen physical and data security. We are applying our deep industry experience across all business functions to guide companies on their digital journey. Supporting companies becoming digital is in our DNA. The efficiency gain and performance uplift is achieved through every part of the value chain, from supply to customer. Embracing digital creates benefits that grow rapidly in a sustained manner. More than that, digital results in the full integration of technology, operations, and behavior, so your workplaces become more secure, resilient, and safer. Embracing digital optimizes field operations, ensuring resources are in the right place at the right time through real-time decision-making, resulting in faster time to restore and increased customer satisfaction. At generation facilities, digital optimization has reduced unplanned downtime by 20%. Historically, electricity generation was utility-scale, linear, and predictable. Today, distributed energy is creating decentralized and increasingly complex networks at a rate that is difficult to predict and manage. With digital analytics and insights, utilities can maintain control of network changes and provide a stable platform for future investment decisions. The digital benefits reach customers with products and services that enhance their connection to your network and resources. Digital enables products and services that are relevant to the customers of today. With customers better connected and informed, you can expect an increase in customer satisfaction, the benefits of which can be shown to improve rate case approvals. Today's executives are facing growing complexity with network supply, consumer demand, and new technology. Embracing digital transforms complexity into opportunity. Together, we can help you remain in control, connected, and relevant.
Yes, thank you for watching it. So we could see that these are all the opportunities that is being integrated or embedded to the customer satisfaction. We talk about the smart technology, smart grid, smart meters, AMR, AMI, and all such things. Whether it is going to be a threat to the customers or it is going to be the happiness for the customers. Yes, it is about the customers, because without customers, nothing can be achieved. We need to make sure that for the customers only we are working on, and we need to give this entire satisfaction level. So that means that whether they are going to be charged more or they are going to be charged less, and whether they are going to be the part of this particular program or they are isolated. So in that case, we need to know about the technology binding. So how this power system need to be worked on. So it's something like the plugged-in vehicles integrated and charging and billing. So if you assume that you are purchasing a new car, so Tata has come up with a new car with a smaller budget. Okay, so we are going to purchase a car means you need to charge it. So today, even putting 100 liters of petrol and going to the next part of the world, It's impossible because we do not know how much kilometer it would give because of this infrastructure. So if road is good, then you would say that it would give 13 kilometers with AC. But if you say that it is not giving more than that, you need to identify a petrol station or the diesel station. But if it is not there, even the costliest car won't run. In that case, the power is very vital. So plug-in vehicles are always been integrated, means we need to think about the charging station and the billable method, or else you would be stealing it from the other home. So increasing grid capacity. So if 5 paise is not a problem for me to give to the vendor, means 5 paise for 5 lakh people, then it is a problem for me. Then again, the network management and load management need to be there, and the real-time pricing should be given. And it is about the energy storage plug-in vehicles. So it is something like it is giving back to that. So whenever electricity people are going to work with mending their lines, the backfeeding or the generators which is work on kills the people. It's hard to digest. A guy who is about to mend the wire is dying because of our poor visibility. It's about the backfeeding. Even a small inverter is going to kill a person. So that means that we need to have the grid security, get inside the data. Thereby, whenever the digital data is not there, analytics or improvement cannot be done. So we need to think about the problem. So it's a threat to the world. So underground power cables, so it is going to be there. So earlier it was all OH converted to UG because of these climatic conditions, all Oki, Varda, or whatever may be the storms that is being named. It is going to devastate the entire state. So in that case, UG is the only options for us. And the increasing grid capacity, asset utilization, and power flow control need to be maintained. So it is about the grid capacity, means we can't go on increase the power, or we can't establish ourselves and wait for the customers to come at a later time. So it is about the power control need to be maintained because the frequency need to be maintained. The grid discipline has maintained 50 hertz. It's even if you rise to 50.1, that is a problem. ABT would be coming into play. So in that case, we need to think about all such things. And network management, cyber security, outage management, remote fault location. So these are the connectivity. So cyber connectivity. So it is something like when we are zero and we talk about cyber, means it's not the cyber. We need to think about the security because someone is peeping into our mobile and watching us, or someone is watching us through digital data. If it is scooped out, and automatically data it is being flushed, and they give that 1 lakh crores of rupees has been given, means if it is spoofed out, means then it is a menace to the country. So that means that everything should be digital and it is transferred automatically. That's how India is working on. So it's a new to still we need to believe that the 1 lakh crores has been reached to the entire country. So that is the digital currency that is being governing. So it is the outage management we need to talk about. It is about the outage management, means we would have Urja Mitra and other things sending SMS. But we could always say that 24/7 company is there. So we could not take up maintenance work. You should not stop it and you should not work on it. And that's how one day suddenly the fault comes, means the entire system is going to collapse. But we need to manage the system, thereby having a redundant source. So that is about them. And about a remote fault location, when there is a fault, GIS and GPS need to be integrated. Thereby, if a grid goes down on that particular area, it need to be identified and it need to be resilient. That is the word that was utilized. So in load management, demand response, local balancing of distributed resources, grid operation is with distributed energy resources, energy storage, stationary mobiles, emergency power, peak power, all such things are there. But I could not cover the entire syllabus throughout the day. But we need to think about these are all the opportunities that is there. We need to think about the grid integration. So in that case, there's transmission, distribution, and generation is there, means that need to be connected through SCADA, and the SCADA data need to be connected to EMS and BMS, and the substation automation need to be done, and it need to be given to the generation. So it is two-way process of communication where the generation, transmission, and distribution are integrated to connect through the enterprise resource planning. So even in offices, e-governance is not that, but we could see that e-office is going to be in utility operation. So that means that the trading is always been governed by the people who are investing there. But enterprise resource planning can give an opportunity for the customers to thereby connecting them, giving back the resources. It's renewable energy, it's an open source technology that is available, means then we need to give back to the society. It's not the costly affairs. So that means that the utility also need to grow and the customers need to be happy. So in that case, what is the data that need to be taken care and how we can give back to the society? So in that case, a capacitor added, it is a problem solving method or it is a problem creating method. Yes, it may be a problem too. If it is not fast switching device, then it is a problem for us. If it is a reactor that is being connected, if that is not been monitored, and it is a problem for us. So we need to think about the digital data with all such connectivity. So GIS and GPS data need to be there. So when we were talking about an AMR system, so one of the vendor was selected, a national operator only. So he just came and congratulations, sir. So you have been selected as L1, and you need to give me 1 lakh SIM cards by tomorrow. He fainted and fall down. I do not know why he fall down. So he said that, sir, it is a great joke that you wanted 1 lakh SIM cards by tomorrow. It is about the network congestion. Already the people get a call, means it is disconnected. You talk about connected devices, always been with a cell phone. Right now, it is going to be your machine talking to your cell phone. So that means that this much network need to be enhanced, means we need to have the power connected to it. Now Swiggy and Ola, Uber is there. So we get all such foods and everything is being delivered. We also need to have such opportunities that our power is being delivered. We also need to have a tracking methodology where the power is being generated and distributed, and if the fault conditions occurs, we need to recoup to restore it. So that is meant. So we are intelligent enough to do that. Yes, we need to be more intelligent. Yes, our intelligence says that we need to get into artificial intelligence. So that means that early 1980s, providing a solution to the complex problem in many areas of the power system engineering was tough and tedious. That is like we need to have any simulation software. So now we could see that ETAP or PSCC giving an instantaneous data that is more reliable, and we also having implemented that. And presently, with artificial intelligence, many constraints can be handled easily, such as economic load dispatch, load forecasting, optimization of generation and scheduling, transmission capacity, and optimal power flow with the real and reactive power limits of the generators. And bus voltages and transformer taps, load demand in interconnected large power systems and other protections, etc., has been handled by artificial intelligence. If human need to interfere, we need to think about a manager who is not on time to the office. He's not there, and so we need to wait for him to disconnect his sir. In that case, this order need to be given, means whether it is intelligent or we need to work on with artificial intelligence. Yes, we need to work on with artificial intelligence only, because we can't pull the guy after retirement, and we need to have such an experiential data that has been trained up to the device. That device need to talk with each other and training everyone. It's something like the information that has been recorded today can be a useful information for tomorrow's kids who are going to grow up. So it's something like it has been recorded and it has been trained in order to bring about the change to the society. With the growth of the power system, complexity in the network is also increasing tremendously. power system analysis by conventional techniques and conclusions from the acquired data. The process for the information management of remote devices and utility became more complicated and time consuming, as it is mother of invention. So necessity is the mother of invention. So that is has been always talked about. So artificial intelligence developed with the help of sophisticated computer tools, and we could see that all the problems has been resolved. Okay, so need for AI in power system analysis. Power system analysis by conventional techniques become more difficult because of these parameters. Okay, so going forward, we need to know what are the techniques available. It is about the artificial neural networks, expert technique, fuzzy logic, genetic algorithm. All such things are being published in all research papers. Whether it has been really implemented in power sector, yes, we need to think about it. The load forecasting has come up with all such ANN and expert system, and right now we could see that genetic algorithm is also playing a vital role, and we could see that all such expert systems are being given, and I need not go in depth into it. I'll just give way to it. Let us have the opportunities that is working on the research enhancement in power system, stability assessment and enhancement, power system control, fault diagnosis, security assessment, load forecasting, reactive power. Again, it is a problem means already researchers are going on. More researchers need to make a leverage. Now Google Meet. Earlier it was a cumbersome work. We need to schedule it. We need to do lots such work. Okay, but now with the Google Meet, sign in, tap it, and connect it. That's it. As simple as it is. So we need to make sure that the power system is not a problem, and all the engineers are turned back to electrical engineering, and no more scavenging for people in electrical engineering. We could see that more than 2 lakh people are coming out, but no such competent people are being given an opportunity to work on. So that means that we need to have the private players to come in, employing more people, so that we could see that even the government sector is uplifting like anything, and no more what to say, like it's not been sold out. So we could see that there is a strain that is there, but it can be cleared very much easily, because all such infrastructures have come up only because of the past experience that has been governed. So mirages in power system analysis. The main features of power system design and planning is about the reliability. So the reliability need to be established. Plenty of research is performed to utilize the current interest of artificial intelligence in power system applications. Okay, what is artificial intelligence all about? So response to situations flexibly, make sense of ambiguous or erroneous messages. So it's something like you have got a lot many WhatsApp, but you see only the loud ones messages. It's about the intelligence or artificial intelligence, I do not know. It is about the natural intelligence. Assigns relative importance to elements of the situation. Finds similarities even though the situation may be different. People think that the pandemic, it is a problem, but we have a lot of opportunities to connect, and we learn more, and we have completed lot many research work, because sitting in home, beating around bush, but we could see that we have completed our research works. Lot of positive sense are there. Draws distinctions between situations, even though there may be many similarities between them. So distinction should be there. So artificial intelligence is the study of how to make computers do things at which at the moment people are better. So that's what been defined by Ellen Rich. Artificial intelligence, Tata McGraw-Hill publication has published it. But artificial intelligence need to have these parameters. Human thought process integrated, heuristic methods integrated, non-algorithmic, knowledge using symbols, where people are better, characteristics we associate with the intelligence. These need to be integrated, and this need to have a constituents of artificial intelligence. So artificial intelligence is the ability of the computer to act like a human being. It's something like we are mirroring it. So think humanly, act humanly, think rationally, and act rationally. So it is about Chitty or new robot that is talking, Electra, the dream Electra. So latest techniques in power system. So line scouting, replacing human works for dangerous and highly specialized operations such as live maintenance of high voltage transmission lines has been long-standing effect in power community. so we could not mend it. So latest techniques have given this opportunity. So I could give an example of the snake arm is performing maintenance at the nuclear power plant in Sweden only, not in India. And this snake robot, it is been integrated with this high quality visual inspection, infrared inspection, checking the condition of splices by measuring their electrical resistance, tightening and loosening bolted assemblies, temporary repair of broken conductor stands. So these are all performed with digital informations only and not through normal intelligence. So that means that the digital information is not only covering AMR, AMI or data forecasting, but we need to work on with this system where integration is very much important. So the digitalization has brought lot many changes, and we need to work on with your AR and VR. So it is about the words that is being given my beloved Steve Jobs, who was a wonderful person. So it doesn't make sense to hire smart people and tell them what to do. We hire smart people so they can tell us what to do. So that is one thing Steve Jobs have given to us. So it's about many such things need to be taken care. So as I am addressing lot many people, I just thought of going forward teaching that thing also. But Srijit sir, how much time I have?
Hello, sir.
Yes, sir. Yes, sir.
The session has to wind up by 11 o'clock, sir.
Yes, sir. So I have only 5 minutes. I'm stopping here. So we will have a lot such things. So if we teach today the way we are taught yesterday, we aren't preparing students for today or tomorrow. So this was also taught in internet only. So we need to work on with this industrial 4.0. So I'll just cover up at a later session. So thank you so much for the opportunity. We can go with the questionnaires. Five minutes only for the question. So sorry for it.
Hello, sir.
Yes, Srijit.
Yeah. Thank you for your wonderful session, sir. Now, just let me post the questions which are already posted on YouTube, sir. I'll just share a file in which questions are shared. 2 minutes, sir. Let me share it.
Sure, sure, sure.
So, can you see the question, sir? I've shared it.
Yes, but it is very blurred. Can you zoom it out?
Increase the font size, sir.
Okay, so yes, now it's okay. It's okay. Great. Respected sir, in the meanwhile, let us know how we can enhance our skills, what type of courses students, teachers should opt to learn such technologies, and are there some resources to learn? For example, we learn what we should learn, data science or automation, but we are confused from where to start with. So very great question Gaurav Pandey has thrown it, and I'll give you a simple answer. Don't think about new such technologies available. Think about your own domain. So whether this domain has a problem, so search for the problems alone, not go away with the problem. It's something like if you are very confident about your domain, you would always search for the new technologies, and we would give solution to it. That's how I can put it forward. I don't want you to discourage saying that don't get into data science or automation, but your confusion resolved only by learning with your fundamental things. If you are not very strong about your fundamental, then it's a problem for you to going forward with a new technology which is not known to you. So it answers, I hope so, Gaurav Pandey. So let us connect at a later time when we are okay with that. Fine. So Aniket Evala, so I do not know how to pronounce it. So nice presentation and explanation, sir. So sir, also talk about power grid sector of India, how they work. So hope I have given the power sector only. So power grid sector in India. So maybe she has given it in he or she. I do not know. Ankit. But the power sector has a lot many opportunity that every engineer is going to be a part of Indian power sector. That is power grid sector only. So because whenever there is a problem with the power sector, it is total blackout. Blackout means it's not that we resume the power within seconds. It is something like it takes 5 days to 10 days to resume the power. We don't see such blackouts occurring beyond 2014. There is no such news in the paper itself or the news channels, Digital India. So, but we could see that the power grid sector has grown a lot, and we need to work on it. But you have asked about how they work. It is a large part of the portions that would be covered. Let's join. Sure. Preeti Das, sir, is there a regulation for standalone wind farms in India? Standalone wind farms, there is always a regulations which been governed by international resources only, but still the regulations doesn't give an opportunity to work with standalone wind farms in India. So standalone wind farms means we need to have larger connectivity. So the voltage and the other transformations need to be modified. If small and micro mini winds are there, then we can have a standalone wind farms. So that is that. So regulations is always been what to say. It is a global nature. It's no more nationalized. It is internalized only. So going forward, we will have such opportunities. Again, apart from standalone solar power, is there any chances of standalone wind power in India? The same questions. Yes, so that would be answered at a later time. So Dr. Vasala Madhav Rao, so she has asked, please cover Solar Alliance in respect of renewable energy promotion in India. Please cover Solar Alliance in respect of energy promotions. Okay, so if doctor has put it in the other way around, like how this solar need to be getting its top role in renewable energy promotion. So that's if that is the question, I can put it in the other way around. So TEDA, so Tamil Nadu Energy Development Agency, likewise a lot of nodal agencies are there. So they are working on this promotion only. But if people can cooperate and have a opportunity to work with such agencies, we can get a promotion as well as we can connect with a larger part of the population. So thereby promoting solar to water pumps, standalone power system in home, and standalone energy, that is charging stations. That is also there. So Ankit Evale, so again the different question, I think. So how hybrid system is different from power systems? Yes, the word itself, it gives the hybrid, right? So hybrid is something like we are talking on our delivering lecture as well as answering the questions through this chat box, right? So it is hybrid only. So I don't think that a separate mobile phone and separate communication system is needed. Likewise, a hybrid system is something like it would be working in tandem with both the technology. So it is not different from power systems. It is integrated part of the system. So we will be working with two different resources. That answers it. Sagorika Raj Chakrabarti. So what about standalone hybrid power system using resources solar and wind? Yes, it's again a very good question. Srijit sir. Okay, so I think the time is over, or that's how disconnected, or I can answer it. Another two questions.
Yes, sir. Yes, sir. The question right now.
Okay,
Yes,
so what
absolutely.
about standalone high power system using resources solar and wind? Yes, solar and wind can be connected and integrated, and we could see that in roadside itself, we could see that wind and solar panels are working in tandem. So in lighting of the street lights. So it is a small high, wind and solar integration. The same way it can have the solar farms and wind farms connected, and we could see that even in Kerala and other part of the country, so where the airports are being powered through solar power and off-grid wind power. So it is something like it can be integrated. So the wind farms are playing a vital role in connecting. So although the passes need to be identified with scientific methodology, if that passes are being identified, then we could see that a lot of opportunities are there working in tandem. Okay, so again the same guy has asked the same questions or different. Lack of encryption in SCADA network, cyber threats are huge. What actions are being taken? Okay, so it's a wonderful question by Chakrabarti. Okay, so it's something like the SCADA network is what to say, like it is encrypted or it is not encrypted means yes, it is always data need to be encrypted. It is not 256, it is 2054 bytes encryption is being given. Going forward, we are going to about to have blockchain technology integrated. We don't have such a problem. So blockchain is a part and parcel of this industrial revolution 4.0. So blockchain earlier data was not encrypted. Now we have a server connected, and so all are coming through only HTTPS and not HTTP. It's something like a secured sites only. Whatever data it is in the consumer segment. So maybe you have asked in the consumer, the SCADA network is encrypted or not means now people are thinking about the encryption. Earlier information was not encrypted. Right now the SCADA where the data is being connected is through IP protocol. So we could see that RTU and FRTUs are come up. The FRTUs are being integrated and it is going through the public channel only. It is through internet protocol. That means that public and private data is sent through the same wire only. So in that case, it is advantages or disadvantages means it is advantage only because we are not having a separate HVDC line or dedicated line to transfer the data. So hopes that answers it.
Thank you, sir. There are still a lot of questions left, but due to time constraint, we are not able to take up all the questions.
Okay, sorry for it. I have taken much of the time. So people can get connected through my mail ID. So I'll just scribble it in the chat box itself so that the people get catch hold of me for any such researches or any queries.
Sure, sir. We'll share your contact details also.
Sure, then. Thank you so much.
Thank you, sir. Thank you for a wonderful session.
Okay, what was the feedback? Can I get the feedback?
Yes, sir. We'll share it, sir, to you.
Sure. Then.
So we have explained all the recent trends in smart grid, demand side management, and regarding renewable energy sources with lot of illustrations and examples. This is really informative and interesting. I think this will really help the participants to have a better understanding about those topics. So thank you very much, sir. Thank you for accepting our invitation and spending your valuable time with us. Thank you very much, sir.
Thank you so much for the opportunity. Thank you. Stay connected. Thank you.
Thank you, sir. So the feedback form has been shared in YouTube live, YouTube chat. You need to fill it before 15 minutes, within 15 minutes, and you have to upload it. And the next session will start sharply at 11:30. Thank you all. The same YouTube link. A very good morning to all. We'll start the next session. The title of the session is Frequency and Voltage Control Issues in Smart Grid, Some Realistic Issues and Discussion. So the speaker of this session is Dr. Nidhul Sinha sir, Professor, Electrical Engineering Department, NIT Silchar. So let me give a brief introduction about the speaker. Professor Nidhul Sinha sir, born in Tripura, obtained his BE degree in Electrical Engineering from Tripura Engineering College, now it's NIT Agartala. Then he has worked in Calcutta Post-Trust as trainee before joining lecturer in REC, now with NIT Silchar in 1985. He obtained his MTech degree in Power Apparatus and Systems from IIT Delhi in 1989 and PhD degree from Jadavpur University on application of intelligent techniques for power system optimization in 2002. He obtained LLB from DU in 1994. Presently, he is working as a professor at Electrical Engineering Department, National Institute of Technology, Silchar, Assam. These are important 33 years of teaching and research at NIT Silchar. He has published around 90 international journal and conference publications like IEEE Transaction, IET, Elsewhere, Silchar, Trailer, etc. Under the supervision, 50 students have completed PhD. He is guiding a number of PhD and MTech students. He is a reviewer in lot of journals like Applied of Computing, Digital Signal Processing, IEEE Transactions and Power Systems, IEEE Transactions and Power Delivery, IEEE Transactions and Evolution Application, IET, Electric Power System Plus, and a lot of other journals. He has given a number of technical lectures in various institutes across India. He has a number of funded projects under MHRD, AICT, and Day-2. He is a senior member in NIT, member IE, and life member in ISC. His area of interest are power system optimization, automatic generation control under conventional and deregulated environment, application of soft computing techniques, technical forecasting, case-based reasoning, intelligent instrumentation, etc. We are really honored to have you with us, sir. So please take this place.
Very good morning, respected coordinators and distinguished faculty members and dear student participants. Actually, I'm thankful for giving me an opportunity to share that some of my feelings which have cropped up in my mind for so many so many days of association as an academician and also researcher. Specifically is I will stress upon the fundamental issues there, which sometimes we go for more of theoretical perspectives without realizing the physical or physics of the whole system philosophy. That sometimes that makes the engineering professors as the mockery of the practicing engineers. I have experienced 2-3 times something like that is there. Like of course people wanted to make mockery of me. Of course I retorted like that. But the question is what? Yes, we have to again go for the looking into that. What we practice in theory, how much is it relevant in the practical field, or when we think about their implementation or their actual working that environment when that same issues are being applied in practical field. So first part, I have heard that some of the UG students are also there, and so because of that, what I'll do is I'll maybe first sometime I'll spend on very fundamental of that frequency voltage control there, and then some of the issues I'll talk about that. I have that my slides are just random picking up of some of the observations in the journals and some experts in this domain. domain. And then based on their the observations or excerpts. So I'd like to that means what the meaning of that means what is the technological implications of that, or understanding of that. That is what. And of course, it is a physical one-to-one interaction with the students, because this is specifically addressed to the students. Because the last part of my talk will be addressed to the specifically the students who will be the future, the contributors or researcher or real contributors in the society. So they have to think in the direction whatever in the last. I'll come out for that one. So the agenda for that is just for the namesake. I had picked up, I have taken up that some slides are there, must be there for the talking or something like that. As the talk goes on something like that, I don't know which way it will go for that. So of course I'll start with that. Means what that discussion should be centered around the frequency and voltage control issues. So the question is what, when we go for the main grid, we talk about the smart grid, then go for the micro grid, go for the nano grid, all these things, the concepts do come in there. How one has to look into that fundamental perspective under that one, and what are being the researches being done in the for publishing some papers and other. Right now I'm really fed up or scoffed up at that the developments are there, that the attitudes would never be at at the the only objective of publishing a paper. No, there must be societal implications. Means what, when that we have to think of that coming down to the implementation of the same issues there, and how much of that are being implemented or very useful to that realistic situations there. So and so that requires that one, when one thinks about that implementation of all the theories being that explored or investigated, something like that. So unless both the things are interface together, joined together, their knowledge is never complete. So it happens there sometimes who are the practicing engineer who happen to be dealing with the very recent technologies, even some of the technologies which are not being even incorporated in our syllabus, in the syllabus. So they make mockery of these people. So we must have to be, as a professional, the professor is there. He's a professor of a professional course must not be less than the practicing engineer. You have to have, means what, that skill has to be very much up to date as of that what is being in practice in the practical field. So without that, means what, that that the professor or that professional professor is never, knowledge of that is never complete in that sense there. And I don't know that I wanted to talk about the different controllers and perspectives there which are being practiced. I wanted to initially thought about that. I don't know that how much of that one will be covered or something like that is there, because it is very difficult in one word lecture making many people starting from the UZ understanding the fundamental. Because if I do not start with the fundamentals one, because some of the fundamental understanding itself will be lacking, something like that is there. So major part will be centered around that one. Okay, and what are the things there, what are we practice, we talk about that in our objectives or something like that, but when we really go for that investigating that same one under the consideration of particular system under consideration or for study, we deviate even from the theoretical perspective. We deviate when we go for implementing that. Why do we deviate? And there, what is the side technical justification for the deviation? Because what we aspire for that, what we aims for that ultimately when we come down with that implementation, means because of that some limitations and other way we just compromise on certain aspects, and ultimately what the question arises about the usefulness of the research studies which are being carried out. And maybe not only that, not irrelevant, means what, whatever research studies are being carried out right now, the thing is what, how they can be interfaced with that, means what, the relevant to the what is being in practice. How much of that one, suppose the same theories are being implemented to be implemented in the practical field there, what else are supposed to be made so that the gap between the practical field and the theories which are being investigated or studied, that can be breezed up that one. So Anyway, that because definitely 1 hour lecture or even 40, 45 minutes, 50 minutes lecture, I cannot go for the beyond that one is there. And of course, because I have told about that means what specifically I want to address upon some of the issues are there, which are the very promising prospects in the days to come. So, some part of that one I'll address to that one. So starting with that, I don't know. This is a very known diagram for specifically for UZ. We go for that. I'm not okay. The frequency and voltage and frequency control of what? Of AC grid, or we can say that one is the AC power system. So how it is done is what we expect that AC power system as a consumer. So the objective of every electrical utility or supplier is to supply that quality power to the consumer. Means by quality power, we know that means we have to have that what is the rated power at rated voltage at rated frequency, and with what, with a reasonable quality of power. Means so other harmonics and other station within the limitation for that. That is what we have to ensure. One very important aspect for this is for the reliability of that. We have to go for that. What the reliability must be a very integral part of that. The responsibility of power system there. So frequency and load is there, and we know that one. This is what that the generation part is what. That here we find out that the voltage is dependent on the excitation. Okay, I'm not going for the fundamental concepts of that. To go for that excitation. Okay, so it's with varying excitations we can vary that the voltage induced in the generator there. That is what. So we know that one. We'll go for that one other one expression for that one. We know that the excitation of the voltage of the generator or the voltage at the terminal generator of the system, we can say that a generator depends on that how much is the power, reactive power conditions in the system. Reactive power conditions in the system means what? How much is the demand, reactive power demand, and how much is the reactive power generation. If there is unbalance between the reactive power demand and generation, then there will be excursion or the variations in the voltage. That will be reflected in the variation in the voltage. Okay. So that means what we find out that the reactive power, the variation of the reactive power means whenever there is an unbalance in the reactive power, that is reflected mainly in the voltage. And it doesn't, if assumption that it doesn't impact the frequency of the system. We just assume, we go for the sum of that because this point is very important for that. Assumption is how much reasonable, that we'll find out that. Our discussion will be next part there. So another one is what? So we have that it is called QV control, reactive power and voltage control. Okay, and other one is the frequency control. Frequency control is more of dependent on that, means how much is the real power, generation and demand balance. If there is unbalance between the real power generation and demand, that will be reflected into the what? Deviation in the frequency there. Okay, that will deviation in the means what? Basically it is what? It will be reflected into the not deviation in the frequency, deviation in the turbine speed. Deviation in the turbine speed. Now we understand that the question is what? That with the variation in the real power or unbalance, that one that reflects into the variation in the frequency or turbine speed there, indirectly what it is the frequency there, frequency of the induced EMF or power generated for that. So the question is what? This it is called also PF control. Who are UZ student, you will be studying for the maybe 6th semester, it's a 7th semester. So it is called PF control and QV control. The question is what? This PF control and QV control are considered to be decoupled, means they are to be treated independently independent of each other. Okay, PF control. Now the question is what? How much is it relevant? How one can assume? You see, in practical generator, when there is a reactive power control or like real power, unbalance is there. So turbine speed varies. So everyone knows that if the turbine speed varies, induced EMF generated in the generator will be varying. Then we say that means what? We are ignoring that. variation in the voltage with the variation in the speed is ignored. How? It will affect definitely. With the variation in the speed means frequency means speed, generator speed there. So there will be definitely variation in the voltage. Higher is the speed, more will be the induced EMF, everybody knows. And lesser is the speed, lesser will be that one is there. So in actual system, it is a combined, it is a simultaneous occurrence of a exactly two systems there, two dynamics there. We can say that two systems are there which are being simultaneously acting on in the system, whereas we are treating that ones separately. Why the justification must be understood for that? Why this justification is there? Okay, second question is what? In our studies of the real power frequency and control, we ignore all the resistances. We ignore all the resistances. We ignore all the resistive loads. Why? Why? All the resistances are ignored. That means what? Can we say that the system doesn't have resistance, which is very much there? We cannot expect that the generators and other transmission lines and transformers that will not be having, even whole transmission line will not be having any resistance. The question is what? How much is it relevant or technically reasonable? One must have to understand for that, because in the subsequent slides I'll go for that. When we go for the distribution system, because for the bigger grid, large grid, the X to R ratio is quite large, whereas in the small system, microgrid or distribution system, X to R ratio is less. So whatever assumptions we make, technical justification we get here, it is not relevant there in the microgrid. You study it. Say 90% research works are based on some theoretical, some model is there. Look for that, who has proposed for some model. What is that model? Say you see that it is something like lots of models are there for devices or every different electrical control, everything their system. What is that model? First order model. My God. What is the first order model? You have 1 by 1 plus ST. First order model. So what will be the difference in this case? No difference, only what will be your T. Oh my God. Everybody understand that one is that this is very, very crude assumption for that. This is when we started for that, that for the Algard and Fossa started for that, automatic generation control, ALS, all these things. That was the long days there. And what we can say after 100 years, 200 years, we have to say something like we have moved ahead. What is the meaning of the way moving ahead? What sense we are moving ahead? We are aging? Some have gone into that, means what a higher level of promotions and other. No. It is never like that is there. There has to be technical excellence has to be there. One has to understand for that what was the conditions or complications which resulted into the assumption of that. All assumptions are meant for what? Avoiding the complexities, given that keeping an eye with what is available today. What is available today with us means what is available means what tools are available today with us, because we want to investigate it, study it there. So when we investigate it, we must be looking at what are the tools available with that, what are the capabilities of the tools available with us. So see, whatever that the tools available, depending on the capability of that, only you have to look for that whether that the system with the given complications we are in a position to address or not. Then we go on compromising. If it is not, go on compromising. But the compromise must be technically justified. What are the justifications? What are the justifications? So one has to look for that. These are the issues, means are fundamental. All may not be available in the book. But the thing is, the fundamental is, this is very simple concept, the electromechanical energy conversion techniques. Oh my God, I'm not going for the fundamentals. So many other issues will be coming for that. In every part of the design of even a coil also. So it is the same simple principle, the electromagnetic induction. Now the question is also why one has to come up with the electromagnetic induction principle. Why not electrostatic principle? Why not chemical principle? Why not solar effect? So many others are there. Why only electromagnetic induction principle? So one has to look for that is there. Anyway, I'm not going for this fundamental issues there. So what we see, what we have seen there, the PF control means the real power, and if you want to control, because you see that we have to supply, you have to give electric supply to the consumers at what? That rated frequency and rated voltage. Okay, so rated frequency, rated voltage, we can expect only when what? We are in a position to maintain the frequency of the system within the limit. Similarly, we are able to maintain the voltage within the limits. The question is what? How? That is what we go for. That is that load frequency control is what? Load frequency control. We look for that anyway. I'm not going through so many other philosophical concepts. I'm not going through a lot more things coming up for that. Is there that has to be. So one need not be constrained one's thought process, the mind in what is proposed in the book means that no, that is not universal truth. One has to look into that, means given the theme, given the perspective, given the philosophy, come out with that. You just set the preamble. And then when you start for the working, then come up with the assumptions. All assumptions are what? Always what? Assume, keeping an eye with the technological tools being aimed to be used. Anyway, I'll just, because that is what I want to strike at, that specifically some elite minds, something like the group there, and specifically with that little bit of students like me, the realization of that one has to look for the fundamental issues for that. Okay, so I am not going for that other issues that you might have studied for that. We are centered around what? Synchronous machines. Synchronous machines as the generator. Then there is a question of what? Because your last part of my slides will be totally different than this philosophy. So right now I am assuming that we are assuming that our generator is a synchronous generator, which may be salient or cylindrical. Okay, that is what there. Okay, so next question is what? We go for that group control. Why I have considered that? See that group control, which is very relevant as of now. Very relevant as of now. One has to, specifically students, you must understand what is the group control, what is group control in voltage control, what is group control in frequency control. Okay, then one has to understand that whether the group control is a primary control or not, and if it is a primary control, then whether it is a primary control is sufficient, how it has to be implemented. These philosophies must be understood, how these are to be realized. The next question is what are the limits? What the first thing is merits and demerits of this group control, because this philosophy will be used not only in this generator, synchronous machines, which is the major generators used in the conventional power system. Okay, so there if you use for that, no, it is same concept also will be used in our power electronics based converters. Similar philosophy is used, but the thing is the concept is different. Philosophies say how is it different, how one can look for that, means what are the implications of that, each one of that, under that condition, under this condition. One has to understand for that. I'll go for this one. I'll try to address some of the issues there. Very warning, I don't know that fundamentally, I don't know, one has to look for that. Not only look for that, understand that. Because you see that the practical field means what you have to defend with, that means what you have to compete with the professional engineer who are directly working on that. They will talk about the group control. And then you have to realize with that means what are the drawbacks. Whenever, I'll go for some of the slides, I'll just mention about that some of the observations or remarks made by those people. Then how do you relate that one with this, that concept, or that means so-called machine-based, electromechanical machine-based, load frequency control to a power electronics-based load frequency control. So that is very important. Whereas that in future means everything will be power electronics-based, prevalent condition for that. We have to move for that. And society is moving. We cannot stop. That one is there. And why we go for that is okay. Another part I'll just go for that. I'll talk about later part of that one. Is the next half will be that half an hour will be based on that part there. Anyway, so I'll just first thing is I'll talk about this one. What is a droop means what? It is droop is nothing but it is a slope, or we can say the drop in frequency with the variations in the real power. This is the PF control. We want to maintain that for PF control. We go for that. This one is we go for that one. This is the characteristic. I think students might have, that over the 6th semester or the machine 2, you studied for the synchronous machine, parallel operation of 2 synchronous generator. Oh my God. Suppose you think about, that power system, that one, which is our national power system, which encompasses the whole country there. There will be thousands of generators. Thousands of generators. So you think about that, these thousands of generators, that means you think of first is realize that the 2 generators connected in parallel. That means what are the characteristics? What will be their characteristics? What do we mean by the characteristics? Means there is the group characteristics there. What will be these characteristics? The group characteristics there. The drop in, variations in the frequency with the variations in the voltage, variation in the real power. Okay. Similar is the concept in the voltage, in the reactive power and voltage. Similar concept there. No difference for that there. So what we do is here in the AGC or ALFC specifically. AGC is the more involved term. More involved term. When you go for that, generation is there. Frequency, load frequency control is different. It should not be treated as generation control. You see that one can generation means it's not in the so-called orthodox generation, because the frequency can be controlled with the variation of the load itself, not by generation control. Load demand response. Then some other issues are there. We go for the smart grid, smart microgrid, and smart energy system, smart energy management. These are coming for that, means what it is much more. Okay, so you come up for that. What do we consider? Okay, general conventional one is, so you consider slope of this curve is treated as a regulation parameter. Is that R is there considered for the regulation parameter? Okay, that is what is there. Okay, but the thing is, okay, this is what is there. We are concentrating on what? First thing, we will concentrate on the real power and frequency control there. So that means how this is considered. How this is considered. Okay, if you look for this is when, okay. So what happens here? Okay, so we have a situation here. You understand that this is what, that we have the characteristic. Same characteristic means what? Drop is, or the slope is same, means characteristic is, group characteristic is same. Group characteristic is same. What you are doing is, we are shifting it upward or downward. How do we shift it upward and downward? How do we shift it through upward and downward? Because of that one, you might have seen that, okay, whoever studied in that, power system generation, for that use the speed exchanger, speed changer part will be there in the load frequency control diagram there. Speed changer part, I don't know, there it is in the diagram. It is not there, I think. Oh, no, it is not there. Anyway, so I've not considered that. Okay, that could have been considered there. So if you have the speed changer part there, that is what is the action of the speed changer is the control engineer, which has to, the control engineer who will be sitting in the control room of the plant, generating plant, not in other plant, not in the other power station. The control engineer who is sitting in the generating plant, he will be looking at that. So what you will see is what? There he will have a knob which is called, means what? The speed changer means what? Speed changer knob is there. The control engineer will be, initiating action. What action means what? With the changing of the position of the speed changer, this characteristic, slope remains same. Only you are shifting it upward or downward. Okay. So the AGC, or the automatic load frequency control, we want to make it automatic, this one, because as the load varies, the frequency will be varying. So to maintain the frequency, suppose what we see is that so what we find is, suppose that load has increased from here to here. This is power. This is real power. Real power is increased from here to here, here to here. If the real power increases for that one, then what will happen? Oh, this one is not there. Okay, you go for that is there. So we not, so if this is the characteristic for that one is there, so you just see that one. Okay, we just go for this one is there. Depending on that, okay, loading condition. So first one is on, okay, this is the one. Suppose we consider for that load is here. That means there is no load. So frequency is, suppose this is our 50 hertz. Then if the load is increased, okay, load is increased by that. So what will happen? So that if we not shift the characteristic from this one to this one, what will happen? The operating point will slide around this. So what will be the frequency? Frequency will be here. This will be less than 50 hertz. It will be around what? 45 or something like that is there. So how to bring the frequency back to here, 50 hertz? What you do is this characteristic is shifted upward. That is what the control engineer, he just changes the position or knob of the control signal. We say the control signal or the speed changer there. It is shifting further upward there. So he make the characteristic shifted upward. Okay. The next question is what? That means what? We want to replace the existence of control engineer. That is what automatic load frequency control. Why the control engineer is shifting that characteristic from here to here? To bring the frequency of the system back to the 50 hertz. That is the one. Okay, that is the one. So when you go for that with the objective of this maintaining the frequency, controlling the frequency, control engineer changes the operating point like the upward, downward, or like that. Under the assumption that the slope is same. You understand the slope is same means what? Group is same. Okay. So now it happens that you see now okay, now the point is what we want to replace the control engineer with this with the automatic one. There is automatic feedback system there. So the design of the controller in automatic load frequency control is nothing but that the control signal which will be replacing that appropriate control signal which will be replacing the control engineer. That control signal is called supplementary control signal. Whereas the control given by this characteristic, control given by this characteristic is inherent. It is called group control. It is inherent. It is called primary control. Okay. Why do we call it primary and why do we call the other one secondary? Technical point of view. One has to think for that. Okay. So I'll see that. Okay. So what will happen with the variations in the load? Suppose you just think about that. This is the load. Current load is there. There is a variation in the load, in the real power. So what will happen? What will happen? With the variations of the real power here, there will be variation, you know, that the operating point will be sliding over this line, around this point, sliding over this line. So there will be oscillations of the operating point around this line. So the frequency will be what? Increasing, decreasing, or like that is what? You have that. What is this? It will happen in millisecond. Means what? Change in frequency. It is not deviation. We call it the deviation is a quite, you know, delayed term. When you go for the change in frequency, means the rate of change of frequency is very important for that. Okay. So this one is what? When you look at that, this point there, here, so this operating point will be switching around that. One is there. So what will happen? Because of this group control action, this one, that some amount of like this one, you might be knowing about that one is there. When you go for the equilibrium criteria and all these things there, around the steady state operating point, how that, you know, that energy, you know, increases, decreases, or something like that, you know, have that one. Similar concept also is applicable here. So what will happen with the variations in the load? There will be variation of the expression of the frequency there. So suppose there is a sustained variations of the load, increase in the load. So what will happen? The operating point will be shifted here. So transient wise, after a few milliseconds to even the moment in seconds to minutes time, the frequency will be, you know, drop down to these values, the fixed value there. In that case, what the action of this primary control action or group control will be over. Primary control will be over. It will be over in seconds time, milliseconds, seconds time. Now means the frequency system is left out with what? Less than 50 hertz frequency there. So what we have to do is we have to shift this characteristic upward or downward, as I said about that. That means the controlling action, which is the other than this group control, is just secondary control. And that control is also called supplementary control because it should be supplementary in nature. Means what? It has to corroborate this one. It has to help that, complement this one. Without that one may work on that, but without this, so this is inherent to that. Group control is inherent to that for the system. Anyway, this is what we talk about that. Okay, so now question is what? When that we are replacing the control engineer with secondary control or supplementary control with the control engineer. That means what should be the controller structure? So many controller structures are proposed. Oh, my controller is giving better than that, or all the different perspectives are there. So one must have to look for that is there. What are the, you know, challenges or competence or capabilities of that one? Why that one? Suppose 3 degree of freedom, 4 degree of freedom, fractional order. All these things means what? Every perspective there with certain. We cannot expect that there is only one medicine for every disease. No, it's never like this. And what I say is what the tactical complexities increases as of now. Old days, whatever system was there, today it is very much different because of what the penetration of the renewable energy sources and lot more other power electronics devices there. That assumption and other even modeling also has to be reviewed again and renewed again. Okay, so similar is the concept. Similar is the concept for that. Just replace this one with a this side is the voltage and this side is reactive power. Same is the concept. Same is the concept. Same is the concept. And I'll I don't know. I'll just look. I'll give okay. Here I'll give some examples. I've just picked up from some paper. Even some of our paper also it will be like that only. What other people are doing and what is missing. You see, what I wanted to just stress out is what is missing. Technicalities must be realized. You see, you are doing something. You must understand what you lack and what you have not considered, and why you have not considered, and what are the implications, and how much is the technical justification of your results. One must have to realize that. You see, nowadays means I am not going for that type of new thing and all this is what. But sometimes I feel very much depressed or something like that. Means at the end of the day means what, or maybe what now it is closing to life. I have to think about that. How much is my contribution to the society? So that sense means for society means to my system, to my profession. Only teaching is not. Then anyway, English or even other teacher also maybe the contribution is there. But the thing is the technical professional teacher, how much is my contribution? Okay, so that is what I said that one here I have taken some of that one. That this is group controller is inherent to that. We come for that. This is suppose we have a system there and group controller becomes what? The part of the system, inherent to the system there. As we go for the AGC here, the group controller will become that one part of the system there. And okay, or that other diagram I could have used for that. Anyway, so then in addition to that, this one we come up with a supplementary controller is nothing but what? Nothing but that the supplementary controller will try to remove that or eliminate the sustainable deviation, sustained deviations in the frequency as well as voltage. As I said, similar is the diagram for QB control. This is PF control. Similar is the diagram for QB control. Concept is almost similar. Only that characteristic, time response, and dynamics will be different. And philosophy is almost similar for that. Okay, so we go for that here. Okay. One more point is here. Okay, yeah, that needs to be again stressed upon. He said, okay. Now the question is what we considered in earlier days. In earlier days, we considered that the system is what there were arguments about that. What should be the value of this slope? Should it be more? Should it be less? There is what we see the regulation parameter. R regulation parameter. So the regulation parameter is nothing but the droop. So we used to, there used to be arguments about that. What should be the value of the droop? When you look for the value of the droop means what? Suppose the slope is more. Slope is more means what? That is the inclination is more. That means with the variations in the reactive power, real power, variations in the frequency will be much more. For any plan which is having higher slope, the variations will be more. So small variation, there will be small variation in the real power or demand. Then there will be wide fluctuations and variations in the frequency. Just opposite one is the slope is less. That means for slope is less. That means what? For the variations in the real power, the variation in the frequency will be less. Now we have to consider same event, just opposite way. Same event. What I say that higher slope means more excursions in the frequency for the variation in the power. And lesser slope, lesser excursion in the frequency for variation in the real power. Now, same event, same statement, we have to look at the other way. That means what? Suppose if there is a variation in the frequency, we are thinking about the variations in the load, real power. What do you think it like that? You think it other way. Suppose if there is a variation in the frequency, suppose you are control engineer, you are sitting in the control room, or you are expert, power system expert, and you are sitting there. You see that there is because you see you are not going for looking at the power variation in the load center, are you? No. You are at the generating station. What you can look at that? Only your frequency and then how much power generated by your plant. You are not going to have the information about all other whole power system. That So what is, as a power system engineer, what you have to look at the control system, the panel board, and look at what is the frequency. Now you see that with the more variations in the frequency, suppose with some variations in the frequency, then what will be the observations on the control engineer? You will say that all the plants which are having higher droop, means higher slope, they are what, with the with some variations with the frequency, that the impact on the plants, or impact on the plants which are having higher slope will be less. Okay, and impact on the plants which are having lesser slope, that will be more. Just opposite concept. Means for all the plants. So now we have to think about that. Like you make the slope more. If you make the slope more, so ultimately what, that the sharing of the load by the particular generator with higher slope will be less, and whereas the generator having lesser slope will be much more. So next question is what, when you want to reduce the slope of the generator, you look at the generator whether it is capable of handling that or not. It is just like that, means, oh, you take some value, so no, it is not like that. That is what control engineer or power engineer has to look for that. He has to look for the dynamics of the capabilities of that dynamical perspective characteristics of the plant. This is the issue. Okay, next issue is what? Here we have considered the slope to be fixed. The slope is fixed. So now the question is what? We can vary the slope, as I said, about increase, decrease, and slope. Because you see that old days we have come up with the mechanical type, fly ball and other, that you have the fly ball, servo motor and all that. This is totally mechanical. As of now, I don't think that nowhere in the world, including even underdeveloped countries also, nowhere it is used. What is used? All, not even electrical sensors also. You have the electronic, or even electronic plus electrical, electronics and digital. So this controllers, you have that one, that speed governor, we say that. The speed governors are, old days it was a totally perfectly mechanical. Nowadays, no. All speed governors are what you call the digital, electronics and partly electrical, because physical device electrical something. So, because ultimately you know that the movement in the opening and closing of that bulb of that steam turbine, in that towards that steam turbine from the boiler, that will be controlled by bulb. So that will be electrical. Even you come out with diesel, a computer will not control that. Control signal, implementation and other things may be electrical, electronics and digital. Digital means computer, that you have that come out with an intelligent algorithm which will decide about the controlling action, which will be amplified through your electronic device, and then ultimately it will be actuated by electrical valve or some other electrical device. There's a combination of three things, but the thing is, it has lot of flexibilities. We can go on varying this. This our slope can be vary. We can think of that depending on the situation. Okay, this is one issue there. Okay, I think it is, to some extent it is understood. I am not going for some many other issues are there. I am not going, because I have not considered the load dynamics there. Load dynamics also this comes in place here. All these issues are there. One has to look for that. Otherwise, simply that little bit of knowledge is dangerous thing. It is better when you say that okay, to some extent you should go for that, and after that you surrender. It's not easy. Life is very complex. I mean, it's very difficult that. Okay. Yeah, I'll just give you that only one example for that. Before I switch over to that. Oh, it is already. Oh my God. Oh, only 15 minutes left. No, I have to skip for that. I think. I can. Okay, I'll just talk. Oh, okay. I wanted. It's not possible, because my latter part is very important for me, for my personal life. Because as a professional, that one is means I have a feeling for these days, means I'm feeling having lot of grudges for that, means what, even on myself also. I want to share for that. Anyway, this part is there. Okay, I'll just keep that one, the one word there. What is there? This is your supplementary control. You know that you say this is the device, the DGs, okay? Diesel engine generator, the wind turbine, this and the you see this one, your slope control and other things, if it has to come up for that, it has to be integral part of the device. Integral part of this one here itself, it has to be. Suppose loop control is to be incorporated here. Okay, suppose you have a converter also, there also group control has to be there, means what, it has to within that one is there. But the thing is, this part is what is the supplementary control, you come up for that. Why it is supplementary control? I am not going to anyway. That is there because it's supplementary to the primary. Because okay, another one is see. Oh my God, this is considered. I've taken it from journal. Or what is the worthless one? Or what is this is 1 over R1? What does it signify? Oh my God, power system. Or you think that what is the power system or islanded microgrid? You think they want diesel generator to present for this one power system and this R and all this thing. Oh my God. So this is very much, I don't know that anyway, I'm not questioning that the person who came up for that this parameter values and all these things they are reported in the journal. Anyway, that part. So anyway, that means what this is what we say that whatever we talk about, these are the supplementary control actions there. The supplementary or secondary control actions there. And this one here is this part is the part of that. You come up for this one. So this one becomes what? Only for this power system, including, so these are treated as simply as an element. It is the load with a okay, that is okay, it's not with the transformer. This is simply represented with the transformer model. Transformer model. Oh my God. Means what here? Here you come up with that. And here, okay. So there is simply a transformation. I said about that means a lot of assumptions and other lot more inaccuracies and other things. They're more realistic and something. Anyway, that one has to look for justify for these. Suppose we consider detailed model. What will be the additional things? What will be the not additional thing? Suppose I have developed this controller, I have developed and designed that controller and optimized the controller with this simplified model. Now suppose somebody asks me question about that. How much will be your that relevant for that or capable that or technically reasonable that your design controller, which assumes that the systems which are very, very approximate. Suppose if the same controller is used in the practical physical system where DEC and wind generator, BES, and even solar also, that will be having what? Physical system there. Means what? Practically, they will have higher, more complex models there. So with that approximate model results, if you use the same controller here, what will be its performance? Okay, it will deteriorate. But for what sense? How much? And how much one can go for that? And how much one can, this is what? Stability, reliability, everything must be. Otherwise, it is meaningless. If you do not understand that one is there. Anyway, oh my God, slides are there. Actually, I wanted to target at that one. When you go for the microgrid, the group control there. When you go for the converters there, oh my God, I don't know. Maybe what? Oh my God, 10 minutes left. I have to switch over that. It just is in the given in the slides there. That the power sharing. Okay, power sharing in the generation. That we have a generation there. Load is there. Load must be shared with the generators. Okay, in between among the generators. How it is done? How it is done? Oh, we look for that economic load dispatch. My God. If we say about that, economic use by lambda iteration method, or the people make mockery. Practical engineers will make mockery of us. They have already made me. They tried to make me when I visited Palatna station. All get out me. They started off with the AGC. When I talked about AGC, they get out me. They started talking about the thing is there. Then I rebutted every perspective. Okay, they have accepted that. One must realize everything there. Okay, you come up with that, whatever things are there, what additional things, what you lack and what more things can be done. So here you come up with the VSCs, because in future you come up with that all this one, power electronic converters will be that very, very much reality. So in that case, you have that specifically this reality. Why? Because of that penetration of the renewable energy sources. You come up with the penetration of renewable energies which are very much random in nature. Now, without the VSC power electronic converter, it is simply next to impossible. And today's situation, power electronic technology is very, very stable, very capable, and professionally acceptable for that. Reliable. Without reliability means no professional will accept for any system they design. So you go for that one. Same is that you go for that power control. They go for the group control there also. The VSC. Okay. Now the question is, I was talking about that. Suppose you have one that AC system. You have that. Suppose your microgrid there, or maybe DC microgrid, and which is connected with that one, or even AC microgrid there, which is outside of that one, that it is having that voltage source converter there, and other side also same one, it has got voltage source converter. Now, how the power sharing, we talk about that, through Thailand it is connected. How it will be done? How it will be practically implemented in the VSC? Means we have studied that one for our physical, power system, where your lines are connected. You have the AC system this side, AC system that side. You have the deviation, the frequency makes that one. So we know that means the power transfer between the two area it happens. If it is AC, then we have to have, even if the voltage is same, power flow may happen because of there is angle deviation. Angle deviation. So all the both the sides, the VSC converters, they have to ensure for that how much will be the angular deviation. That angular deviation must be related with that what is your tie line exchange, whether it is a agreed tie line exchange or what means what we have the scheduled tie line flow, which is after agreement it is decided that during this time this much power should be transferred from here to here, this area to this area, this area to that, like that. And to ensure for that, how much is the how this philosophy will be practically implemented for that. And that too also is coming with that one is you come up with that one is group control their philosophy, group control philosophy, because you go for that same one, the variation in the frequency. You go for the variation in the frequency with the characteristic of that. And another thing is what, with the BSC inverter based that one AC system there, where the response is group of that one response is very fast. Response is very fast. When the response is very fast, I don't know that whoever is they have studied for that. The fast excitation systems there. That fast excitation system was proposed to improve the what transient stability of that. So within very short possible time, the variations in the excitation of the voltage that will be taken care of for that one. But it what endangers the steady state stability of that. So to improvise for that one is there, we have to go for the power system stabilizer concept there. This is some of that one. So anyway, so here what is there? They have gone for the group. So here another part is this, that when you come up with a mixture of that renewable generators there, some will be having inertia, higher inertia, some will be having lesser inertia, non-inertial DGs are there. The rate of change of angle in the VSC interface with the DGs are limited to the rate, same rate as those of the inertial DGs, because the DGs which are having less inertia, their rate will be very fast. And for others having inertia, I'm not going for the who are you might have understood that what DGs are with higher inertia and less inertia. So for that, so ultimately what the DGs interface to that one. So what with those of the inertial DGs. So for that better coordination between the two type of DGs there must be what it has to be limited to that. Even if it is acting very faster, able to act very faster, it should be kept at the same rate of those of the inertial disease there to maintain the same rate of change in the power output there. Anyway, so ultimately what this fast acting that the VSC is, they will result into a very short time power management for that one is there. But the thing is it will again endanger that from the better power sharing and other perspective. It means for power sharing is nothing but it is a long-term perspective. It is not short time. Short term, we are not supposed to look for that. That is the one total primary control concern for that. Only secondary control has to look for that is the long term better power sharing. What is the meaning of better power sharing? More economic sharing. More economically sharing. The sharing has to be more economic. Okay, that is the concept of that. Anyway, that I'm not going for that. Oh my God, it is already going to be over, I think. Okay. Oh my God, no, I'm not going for the smart time. I'll just add one thing here. This is my realization. All talk. This is the definition of smart grid, smart energy system, or something like that is there. This is the definition is that. What is that? They think that it is a combination of system. It may be a smart system, or any energy system, or any other system there, and together communication system, and maybe what IT may be there, the connectivity there. Oh, my addition to this concept is what without intelligence, it will never be smart. Suppose I am a human body there, and all the limbs are connected with that. Does it mean that can I say that I am smart enough? Definitely not. So only connectivity of all the subsystems with the full whole scale connectivity with all the subsystems in that one, and with what information better information or that information gathering, and that like the information technology, all this, that one there, and that makes the intelligence smart. Intelligence is the very basic element for the smartness. And here it is talked about the electric power or energy, whatever is there. That is what the system, the communication infrastructure. IT is there. The IT makes this what that we can think about. That IT is nothing but it is the area basically. We can talk about maybe what it is some sort of what cyber physical world or something like this, what intelligence may be included in this particular domain part. But it is never specifically mentioned. Nowhere it is specifically mentioned. Anyway, I'm just looking for that. Like I'm not going for that. There's a different thing there. You may when you have time. Okay, one part is there. When you go for the microgrid, that DC microgrid, I was talking about that. Oh my God, no, 2 minutes. Okay, okay. You see, this is very important. It is to the core of my heart. This one is there. You see, DC microgrid. I'll be jumping to that. I'm not jumping to that. One part there. This one. This is a slide. Just why I'm just looking for that. Ordinary comparison of ordinary 5-star rated, fan and BLDC fan. 5-star fan and ordinary fan. Just see that about that. See the comparison. As the speed varies, when the lower speed is there, we don't expect always that the span of the speed of the fan will be always highest. No, it may not. Just see that how much is the power level differences. Efficiency, suppose that one normal one is coming out to 35% efficiency. The BLDC fan is almost 70%. So much higher. So BLDC fan or BLDC technology is very relevant as of now. But there are some people who are not advocating for that. And this will be very relevant for when you go for DC microgrid. When you think of DC microgrid, that is what when we think of DC microgrid, we don't require the frequencies, only voltage. The system becomes so simple. Illegal tapping, even so many things, tracing, everything becomes very simple. Very simple. So everything becomes very simple. So only the problem is what we have to replace all the AC home appliances with the BLDC technology. I have not included here. I have seen so many others are there. You just got the compressors are there, which are used in our AC in washing machines, in air conditioners, in freezers. I have already records there already. Already some companies they're trying to make it there. And what it is there means what if you just here, I have given here they got BLDC motor, brass DC motor, and AC induction motor. All all compressor motors, and then we come out with compressor motors used in washing machines, used in ACs, used in your freezers. All are AC induction motor, single phase induction motor. Now, if they are replaced with BLDC motor, you cannot imagine there will be drastic, improvement in the energy efficiency, power usage, and we know that also all our houses are now DC based. You go for TV, it is also DC. We use an adapter. What is an adapter? It simply converts that 230 volt AC into 12 volt DC. And you have the CFL bulb, that is also ultimately what? The DC based. So everything is DC based except that high power machines. That machines also can be made. BLDC motors are, as of now, because of the huge development in power electronics, it is very much reliable. Efficiency, there is no compromise. No comparison with other machines. But the only question was reliability. Reliability is because there is no maintenance. Like other DC machines, this doesn't require because there is no brass. So very important part means I want to make means what? Why not you make it? Wind energy, wind turbine coupled with BLDC generator, not motor, because the performance of anyway machines. Okay, BLDC performance efficiency is supposed to be BLDC not machines, not motor. Motor as well as generator. Machines are almost at par with the synchronous machines because they are doubly excited machines. All the doubly excited machines are much more efficient, much more competent. Very power to weight ratio, very effective. Beyond comparison with that, induction motor is the most inefficient one. Electrical machines. So so one has to go for that. This is not done. So I want that means that there one must have to come out with that one, that technology there, replacing that all this one, the wind turbine, that all other your DFI. What you'll do with DFI is so complicated one. We don't require anything. With you use the BLDC and you the DC is there. You have that DC, DC to DC converter sufficient that you have that is there. Once you come up with that grid is there. I'm not going for the microgrid and other concepts that will be already people you will be studying for that. Okay. So okay. Anyway, that that you come up with, just imagine that one can take the study of this one, the BLDC base. Suppose you have a building, like the metro cities like Delhi, Mumbai, or something like that. So one building has 40-story building there, almost 300 flats are there. Just imagine that 300 flats. There will be all the that we say that one MIZ and LIG, large income group, medium income group. That just imagine that minimum 2 to 3 ACs will be there. There will be washing machines, pump also. Pump wherever that high power appliances are all are to be replaced with the equivalent one. Just study that economically. This one, that whatever the AC counterpart, compressor based that one, and DC counter, there are list available there. Same rating there, same power rating with that AC compressor. Okay, then equivalent that same power rating, how much will be that power rating of that your this one power requirement of your BLDC, and with that see that 300 flats, almost 600. Every flat will have 2 to 3 ACs will be there, washing machines, freezers. The freezers also maybe more than that. Then you have that mixies and other grinders. So many other like issues are there. All maybe of course mixies are already that one. They come up with the DC type that one. They are DC on. So go for that. So they come up with the conversion. So in that case, what happens here? Just have a study of that. So ultimately, what your whole building may be treated as. So all buildings will be having a what in 5 years down the line. Majority of that one people are supposed to have the electric vehicle. So you have minimum 300 flats is minimum 400 electric vehicles will be available. You come up for that means what IoT based devices, which will ensure for that is that nano grid. It is not micro grid. One building will be treated as a nano grid there, and 2-3 buildings over there. Means there may be exchange of the power from one to others like that is there. That may be what you can have that because if it is a DC level, it is so simple. I don't think that it requires electrical engineering degree. I can bet. If it is perfectly DC, if even an ITI pass if is given, because he is not going to design the system. Design requires engineers and others like that. Once you go for implementation and connecting these and all these things there, they are quite competent. People can come up with so many issues of that. IoT school kids, school students are coming up with a lot of IoT applications for so many intelligent use of so many appliances. Why not home appliances go for that? So every building will be nano grid. Then 2-3 buildings having that one connection of that combination of that one is there, and this combination will not be a big one. So you come up with that means the loading of this all that whole building 300 flats will be can be made very planned and through IoT based means for that the scheduling of the loading can be made in optimal way. Use of the energy can be made optimal way. Even because I have heard it for the some of that issues which way which should one should target for that one society should target for that zero energy building, zero net energy building there. So that has to be well design of that choice of that one that has to be planned for that. Anyway, this is some of the parts means I felt for that. I'm not going for some other issues are there. So many issues there. It's not possible. It is already over. So much time is there. Srijit? Hello.
Hello, sir. So it's done, sir?
Yes, you can think of that. Now the rest part they can do means what it is too much something like this. I can go for that each part of something like that, but okay, you can see that. If specific students have the questions, I don't know what level they could understand or not, because these are fundamental issues or something like that.
Okay, sir. Actually, they have raised some questions. I'll share it in the screen now, sir. 1 minute, sir.
Okay.
Can you stop your presentation, sir, please? I'll just present the screen.
Okay. Because I'm not targeting so many other issues there. Anyway, I'll just see that.
Are you able to see the question, sir?
Okay, what is the limit of okay damping cost? Oh no, okay. Ritu is there, okay. What happens, you know, that I don't know that you understood that? What is M? You see, you have to understand that what do you understand by the inertia? You know that any rotating body, you know, in a classes there is one single, you know, synchronous machine connected to infinite bus bar. My God, of course one has to start from somewhere, no, from zero one has to start. But real life is so many, you know, so many machines are connected for that. The question is, suppose 10 generators. I have a plant there, same plant, there are 10 generators. How will you get the inertia for the 10 generators? There are methods. There are methods for that. Different type of, you know, like a pole placement methods there, and dynamic currency based methods there, and then some other also that same dynamic analysis based that one is there. Come up with that. Similar is the concept for the damping constant also, because this is the dynamics of the damping constant in normally what? You know that when you consider for that this limit, why? What is the meaning of the limit? This D represents what? This represents means what? That the because of the variation of the power. No, what is not power? Is the frequency. Because of the variation of the frequency, how much is the absorption of the power? By the suppose what this is considered as what induction motor. Induction motor, you understand that the frequencies increase, speed will be more. So power absorbed by the motor will be more. So if the frequency is little bit, but the thing is what is it very tactically reasonable to consider that the loads are represented only with the motor load? Not always. So specifically, you come up with that one distribution system where is the microgrid. No, it must have to come up with some other elements will be there. So whether it's mathematically, it has to be one addressed. Whether we are competent to address to that. Other one is what if suppose not there, what additional elements should be considered so that which are ignored practically, physically there, but we are ignoring for that. What will be there? So now we have to understand that what are the other parameters which are ignored. What are their dynamic impacts? That must be kept, kept in mind while considering for that. So these values are dependent on the system only. System only. There is nothing limit or nothing like that. You have the larger system, the bigger size machines, the inertia will be more. Small machines also in the microgrid means what inertia is very less. So there are wide fluctuations in that. Very wide fluctuations in the frequencies and other part there. In case of infinite grid or some of the very large systems there, and their inertia will be very, very large, very high. There is no limit, nothing like that. Why the limit will be there? You connect 1,000 machines together, 1 lakh machines together there. So who stops you? Only the thing is what the machines are connected together. You have the network available, which should be capable of exporting, importing, means that exchange of power means what? Carry that power. How much power to be carried and flowed about that network? It depends on that. Okay. Ritu, next question is okay. Oh, okay. Next one is okay. Good. Why we are not using BLDC motor? You ask the people who are not using, not me. It is easy to yes, it is not. But the thing is what you will be surprised that we have whatever we are using for that electronics world, electronics gadgets, 90% comes from China. Now everybody you are because it is you people buy. We have already reached to our end of our life or something like that is there. Professional life is there. We have no dependent. But the thing is, it is your life. You have to come out with that. You see, in the China, you go for that. Yes, small, the small cottage industry. They look for that hardware-based, devices they are making. We have to start. You have to start. All young guys, you have to start for that. It is not big thing. Motors are available, and you come up with it. Apply them in the different situation. It is very much, and definitely, I am And I can give you guarantee that its performance will be far, far better than AC counterpart. It is basically BLDC motor is nothing, it's not motor. BLDC machine is equivalent to a synchronous machine. Synchronous machine. You know that synchronous machine is the most efficient one, other than transformer. Transformer is different. That is a transformation there. But the energy converter, as energy converter, that synchronous machine is the best one. Okay. Okay. Sri Prakash there. While using the speed changer, increasing the flow, we have shifted the slope to increase the level of that. No, it is not. Actually, what you know that Prakash is what? I don't know that. You know that when your speed changer doesn't make the operating point to shift on the curve, sliding over the curve, it makes that one, the curve itself will be shifted upward or lower. Suppose if it is shifted upward means you go for the raise. You know that the raise and lower two commands are there. If you make it raise means what, increasing the generation, so that line will be lifted upward. If you lower means that decreasing in generation, line will be shifted downward. That is how. And automatically what, once you shift it upward and downward, the operating point will be automatically adjusted to the new operating point on the new line. And say that in the new operating point, the frequency may not be as desired. Again, you go for the maneuvering. It is not one way. So you know that also when it changes, that when the control engineer he does it. I don't know whether you have visited any practicals. I have visited them. Not visited. I underwent training in atomic power station. And if you happen to get that opportunity to get training, you better go to that the nuclear power station, because nuclear power station engineers are the most competent engineers. You cannot imagine, because there you are not given more than few minutes time to think about that your problem you are facing and to solve it. No, I have experience there also. In front of me, executive engineer was, he was sent back to that. In front of we people there training. He was sent to the training section for 1 week training for refresher. So if you want to learn really something, go to that and you will really find it. Okay, CVIP, good. Okay, understood that the smart microgrid is really smart, users friendly. Yes, it has to, because once you have the smart means what, you have to exploit all the possible means. Tactical excellence, managerial excellence, economic excellence, everything is possible. Means what, one has to make it possible, intelligence must be exploited. And you have to have the tools which will enable the use of this. Means what, first thing is you have to get the information which requires information network, and other one is what, that the flow of the information and the controllability there. Other effective controllability, that one is there. So it is very much relative for that. And you go for the DC grid is there. When you cannot imagine future, everything will be like that. Means you cannot imagine. And one, you just come up for that. So what is that? Okay. Zero net energy building is nothing, but it is not the zero energy building. It is a what? It is that around the 1 year, during 1 year time, whatever amount of energy you have absorbed, you should be able to supply that one, so that the average is zero. That is why it is called zero net energy. So because during some of the time you should be able to supply it back, okay, and some other time you absorb it like this. This is what the concept of zero energy building, and it has to be, because in future probably in government after 10 years down the line will come up for the all new buildings. They will have to look for that, as I said about the some features I have to make for that, how to make a home energy compliant. It is not actually home, it has to be a building there. You design it there, and it has to be not holistically. Holistically is the concept is there, but the more is the tactical perception, that in terms of the your maneuvering of that windows and all these things there. Windows also should be replaced with, that means the solar panel. You come up with the turbines, a micro turbine. You see, as you go for higher and higher height, specifically that this can be exploited in that, I don't know who are staying in the nearby the airport. If you go the nearby the airport, you will find out that some of the that the buildings where they will be experiencing lot of like Mumbai, Delhi and Calcutta airport, something like that is there. They will experience huge turbulence because of the flight going landing and taking off. So that's the best place. Means one has to look for the smartness. Means that is what you have to see that what are the issues and what are the importance there. You have to think smart. Why? Where wind energy, solar energy, power supply, get inertia. Oh my God! Okay. So you know that means, you see, inertia, as I say, you have to think about that. Whenever there is a what, I'm not going for the ideally what inertia means, it has to be associated with a physical, device. Physical device there. Okay. Okay. Solar energy also is a physical device. The only thing, physical device about what? Device means what? Appearance? No. When the device is in dynamism, then only the inertia concept comes. You know that any rotational body is supposed to be associated with inertia. You know that is there. So wind, you have the inertia is there. In solar, you don't have, physical movement is there. Where there is not much inertia there. But the thing is, suppose you use that one, some systems there. So in normal case, what? Suppose we come up with a system which is very, very fast. That means for instantaneous. How do you deal with in our dynamical system representation or system representation? One must know that. Okay. What is that? Patil is when two microgrids are interconnected, how the generation is shared when there is disturbance, maybe load tripped or extra load trippers in one of the grid. No. Microgrids are what interconnected, what happens in the shared. No, you see that. No, I'm not going for then I said about the microgrid. The concepts of microgrid is what? How is it different? Microgrid is different than distribution system. Is the distribution system a microgrid? Or is the microgrid a distribution system? Okay. Actually, the concept of microgrid, I'm not going with all the detailed part of it. The basic fundamental concept of microgrid is what? Every microgrid should be treated to be an independent system. What is the independent power system? What is the meaning of independent power system? Independent power system means what? Under the standard circumstances, normal conditions, that the microgrid should be able to maintain its demand from its own generations locally available, distributed generation locally available, or even suppose it is a grid connected one, then from the grid there may be a tie. You can think about the tie line or something like that. Exchange with the grid also may be what done with what intended for that. Means only on the distress condition or under schedule agreement only it should be working on that one. When the two microgrids are there, when there is some problem in one microgrid there, that means it depends on the other one. So if the other microgrid has to work for that, is there means for normally if it is a cooperative interconnection there, then they will look for that sharing has to be what? When the other microgrid which is healthy should come forward or not. Depends on what are its generations available. This generation also is called what? That I don't know, the fast energy. It is called fast energy. You can see the technical term. Fast energy means what? You have a generating, energy sources, but some sources are not able to respond very fast in millisecond time. So other microgrid which is healthy, whether it having that sufficient, fast energy to take care of the other one, how much is that one deficit in the other troubled area? Depending on that, they will decide for that. Can be done. What is load frequency control or two area power system? Oh my God. Okay, that is already covered, I think. Every area will be independent, as I said, a microgrid. Every area will be independent, treated as an independent system. Okay, so every area should be able to what? So if the two areas are connected together through tie line, that connection is called tie line. So then that connection will be what? This connection will allow the exchange of power between the two areas under different conditions. Normal condition, the exchange should be within the scheduled tie power or scheduled power, which is agreed upon by the two, both the area owners. Okay, and suppose there is a disturbance in one, so that the other area may come forward, healthy area may come forward. But how do we do that? How do we do that one? How it is controlled? That is what we go for, that area frequency response characteristic beta. How we go for that area, because this is the issues which are, because the AC is there, the frequency is there. My God, that complicates whole system there. Means you have to understand whole philosophically everything there, because so many things are mingled in case of AC system. But the DC is so simple. My God, that is what. As you told, starting of your session, only we are ignoring resistance. Okay, why we are ignoring? Because we cannot consider resistance. Because if we consider resistance, because with consideration or with ignoring resistance, the self system becomes very complex one. The size is the problem with what electrical power system is the enormity in the size of the system. So big, it is very difficult. As I said, you had one plant is having 10 generators. Like that means you have the 10 plants there. Just imagine that 10 plants located in the different situations there. And then what are they ignoring? So you consider that the transmission line which connects that 3 plants, generating plant, each one is having 10 generators. First, you have every plant to have equivalent inertia or equivalent parameters for the 10 plant, which is to be represented by only one machine. Similarly, another plant, equivalent generator, another third one. So you have 3 generators, basically 3 areas. Every area will be represented with only one equivalent machine. It is not the real machine. So means when you go for the 2 system, that one is there. So it depends on that. So load with the means we consider only reactances, but of course there is technical reasons, technical justification, not reason, it's technical justification. We are ignoring because there are technical justifications. Means what? Why? Because why that even with that one ignoring that resistance, results are applicable, reasonable. They can be made relevant. They will be relevant for the real life engineers or practicing engineers. Okay, inertia issues are nowadays solved using. No. Inertia, that is okay. That not only that one. These are all that there are different issues. That as I said about that, even if you go for that, you see, you have energy storage systems also can be treated as your type of generators, distributed generators. You see, energy source element. This is basically okay. What is the difference between a machine, rotating machine, as an energy converter and a battery? Both are producing same that one. Sometimes it will absorb, and once it will be acting as a work. Of course, additional per charging will be there. But the thing is, when it acts as a generator, principle is similar to that one. You have the DC machine similar to that. It is not. So, but the thing is, dynamics are definitely involved for that. So nowadays, solve means what? These are basically used for that because of that, because the randomness of the renewable energy sources. When we require the power, their generation may not be available, and that displacement from the that availability of generation and that demand requirement both are at different time different. So to balance up that one, we go for that some sort of energy storage devices and all this. But they must be kept in mind. We go for the suppose you go for that ultra capacitors and others. Then why one should go for that? What type of capacitor, ultra capacitors one should consider? What is the capacity of that? What is the basis technical consideration for that? What is the technical method to come up with that capacity of that? That one must realize. At least what if you don't know that principle, you must know. If you don't know mathematics, okay. But the thing is, what when practicing engineer will talk about that one, he will be knowing some thumb rules there. You must know the why what are the issues and principles should be considered while choosing for this. That is what I am stressing on that. Okay, any more? Srijit?
Hello, sir.
Mm-hmm.
That's all the questions from participant side, sir.
Okay, good. Thank you. Thank you. I think some tried to address some of the issues. Okay, good.
Yes, sir. Yes, sir.
Some are from PG, I think. Some are from PG, I think they have asked about something.
Yes, sir.
Okay, good.
Okay,
good.
sir. Thank you very much, sir, for your wonderful session. You have talked on microgrid, its issues, voltage control, troop control. Then you have taken the comparison between BLDC as well as induction motor. So I'm sure that your expertise and experience in this area will have helped the participants a lot. Thank you very much for accepting our invitation and spending your valuable time with us. Thank you very much, sir.
Thank you very much to you all, who are the organizers, specifically coordinators, giving me an opportunity to share my feelings, that to the young generations, that one. I've been wherever I get the opportunity, I just count on that. Go for the DC, microgrid, not DC systems, everything there with the VLDC. Means in future means, of course, it will lie in that one. And the whole life will be made really smart, not only energy in every perspective. Thank you very much.
Thank you, sir.
Okay.
And for the participants, the next session will start sharply at 3 o'clock. Thank you all.